Okay, hi students. I hope you are doing well. And am I audible right now? Let me know if I'm audible. Right. Okay, so let's wait for a few minutes and then we'll continue. Okay, so we'll be continuing with what we left morning. Okay. Yeah, I am live streaming in YouTube. Now the YouTube issue has been sorted out. So y'all can get into the YouTube if you want. Okay. Right. We'll wait for 5 minutes. Morning. I mean, like not morning. It was like, yeah, you can go and pray and come back. Those who want to pray, y'all can go and come back because I'll be starting by 6:40. Yeah, the current is available right now. I mean, the power is right now here. Uh, I don't know. Some places, some people are texting the power cut is now. Some places. So today we learned about motion in a straight line, and then we have to continue with that since due to the power cut we could not continue, right? Okay, so let's wait till others join. I'll be starting by 6:40. Those who wanted to pray, y'all can go and pray and come back because I have to continuously move on. Don't know at what time again there will be a power cut because since they told there is a schedule related to the power cut, but they do not follow according to that. So I'm not very sure about it. So let's move on. Right. I have already shared the recording in the channel. So the you can just click that and you can get it. I have already uploaded. I have already uploaded the recording. Today's afternoon recording has been uploaded. I have already uploaded so you can get an idea. Right. I'm waiting for 3 minutes and then we'll start. Okay. As I already told you, so we will be focusing with certain lessons today. And then we will be having another session related to that because physics, we can't study everything at once. But I'm giving my maximum and we are going patiently, okay? We will learn everything patiently, right? Okay. Okay, most of them are saying that there is a power cut right now. Yeah, right now. Okay, no problem. I will be continuing. Y'all can get the recording, right? Yes, we will have it until 12. But if you make it as a recording, it will be really complicated for you to watch because you know it's a recording. But if it is a live, you know it's a live, so you will focus more. But since it's a recording, you're like, okay, recording, I can watch on another day. Again and again, you will like, okay, another day, and next day is your exam. So you will, it's our mindset. We feel like that. Right. Just one more minute because I have given others to pray, so I don't want them to hurry. So let's wait for a minute and then get started. Okay. Has everyone started studying right now? I mean, like, I know few of them have started studying from 3 months. I mean, before 3 months itself. Hope, Seema, you will get. So others are on the track. Okay, no worries. As I told you, if you are studying science, if you are studying science today, study only biology like that. Tomorrow, physics. Day after tomorrow, chemistry. Don't study all the competency at once. You will feel difficult. So better you can divide it. Now, someone asked me, I could not remember. Okay, someone asked me how to study science within 34 days. I told you you can complete the syllabus of science within 6 days. You can even take 12 or 6 days. You can finish it by taking break, because we know that we have 10 lessons in biology, 10 lessons in chemistry, and 14 lesson in your this one, physics. So when you have these lessons, now when you have these, what you can do is, if you take one day, if you take one day for biology, if you take other one day for the physics, if you take other day for the chemistry, so if you can divide those 10 lessons into two, if you can 10 lessons into two, you can get it. No, that means one day 5 lessons completed, other day 5 lessons again, here 5, here 5, and here 7, here 7. If you can complete within 6 days, you can finish it off. If not, if you want, you can more break it down and take 12 days to complete your whole syllabus of your science. But I don't recommend you to take 12 days, because 12 days is not enough. I mean, like 12 days is too much, because you have mathematics, you have first language, you have a lot to learn. So focusing on science won't be, I don't think so it's practical. But you have to give importance equally, you have to give importance for all the lessons equally and all the subjects equally. So that's the reason I told you. But this is a better way of learning. If you're studying all of them together, you can't learn, but you can do it. Okay. Yes, I will be discussing questions and all, no worries, okay? So you have to stay till night today, so then only we can do it. Right, okay, let's get started. So, under the second chapter, you have to learn few things. Under the second chapter, now since we know motion in a straight line, no, so we were talking about motion in a straight line. Now, I told you this lesson is very rare, but sometimes most of the graphs can come. In case if it comes to your MCQ, if it comes to your structured, or if it comes to your semi-structured, there can be this lesson. This lesson can be there. So you have to keep on eye. Right, listen. Now, when you talk about this motion in a straight line, already we studied about acceleration. We already studied about velocity. We already studied about what? What else did we study? So already we studied about acceleration, already we studied about velocity, already we studied about distance and the displacement. So we have learned a lot, and distance and displacement, and then we have studied about what? Speed. We have studied about speed. So we have learned all of this, but in this lesson, at the last part, you have something important there. Most of my students, they get wrong at that point. I'll tell you what is that. Have you ever seen a question? Now, have you ever seen a question? They say there is a fruit attached to the stalk of the tree, and it will break down and find the height from where the apple or the mango fall from, and they will ask you what can be the velocity, what can be the acceleration. Have you come across with kind of questions like that? A fruit is hanging on the tree, and they have asked you something like that. So some of them will have kind of questions like they have faced during their term papers, mock papers. You have faced such questions. Have you ever felt that question is hard? I'll tell you. Yes. Let me talk about it. Now listen, under this part only, under the fruit part only, you are going to learn gravitational acceleration. You will be studying something called what? Gravitational acceleration. So let me talk about what is gravitational acceleration. Now say this is the earth. Now when you talk about the earth, now we all of us are or inside the earth, or are we floating around the earth? We all of us are pulled, no? So we all of us are pulled towards the center of the earth. So the force which attracts an object towards the center of the earth, we call that as gravity, or we call it as what? Gravitational force. What do we call gravitational force? Now, why are we on the earth? If they ask you, why are you on the earth, not in other planets? Because the earth has gravity. So when you talk about gravity, in another term, we call it as gravitational force. Why do we call it as force? Because earth has pulled us. So force means what? Push or a pull. We call it as force. Now since we know all the objects on the earth is pulled towards the center of the earth. Now whatever the object surrounding is pulled towards the center of the earth, that we call it as what? Gravitational force. In another term, in your other language or in other term, we call it as weight. Now say, because of our weight only, we are on the earth. In case if they don't use the word weight, you have to remember that's a gravity. If they don't use the word gravity, remember that's gravitational force. So all three terms are going to be considered as what? One. Clear with that? Now since we know it's a force, what is the unit you measure force? We used to measure the force by what? Newton. Now think like this. Now most of us make a mistake. All of us do a mistake. We say that my weight is, now say for example, my weight is 60 kilogram. I say my weight is 60 kilogram. Now when you look into this statement, now I told you force, gravitational force, gravity, weight. All of them are same. All these three terms are same. That is measured by Newton. Now when I say my weight is 60 kilogram, if that statement is correct, can I say my weight is 60 kilogram? Can I say? Cut. It is wrong. Why? Weight is a force. I have to tell I am a 60 Newton. I have to tell I am a 60 Newton in case. Now since it's a kilogram indicates mass. That means my body mass is 60 kilogram. So if I want to my weight on the earth, if I want to find my weight on the earth, what is the equation should I use? Yes, just now I started. So what is the equation should I use right now? If I want to say my weight, what is the equation? Weight is equals to mass into gravitational force. Always remember the gravitational force on the earth is 9.88 meters per square. But just to take approximately, we think as 10 meters per square. So what is the gravitational force on the earth? Approximately. For the easiest calculation, we take it as 10. So already gravitational force you should know. They will not tell you the gravitational force every time. Sometimes they can give you, but generally you should know the gravitational force should be 10. Now if I want to find the weight, how do I find my weight? What is my mass? My mass is 60. What is my gravitational force? 10. So 60 into 10, my body weight on the earth is 600 Newton. So this is how you give answers to your questions. Clear with that? Got the idea? Got the idea? Now let us come to the question that is related to your exam. Let us come to the question that is related to your exam. Now in the exam, they can ask you some questions like that. Now before that, let me tell you something. Now for example, you have a ball in your hand. Yes, Hazma. That's fine. It's okay because I have done some few settings. I couldn't change that. It's okay. You can be there. Because I have not changed the setting to rename. We'll see. Okay, it's okay. Right. Look here. Now let's say for example, you have a ball. Okay, you have a ball. Now you throw up the ball. Now you throw the ball up. Will the ball keep on going up or will it go up and stop and fall off? What will happen? Will it keep on going up or it will stop and come back to the earth again? What do you think? Say this is the earth and someone threw the ball. What will happen to the ball? Very good. You throw the ball. It will go for a certain height. It will stop and it will come back. Okay, now listen.
Now we know that when I take the ball and I threw the ball up, it will go up to a certain level and it is coming back to the earth. Now tell me, why did it come back to the earth? A general question from you. Why did it come back to the earth? Now you jump. Will you keep on flying or you come back to the earth? What is the reason you come back? Very good, Mariam. Very good, Joanna. Very good, very good. The answer is gravitational force. So, due to the gravitational force, you are coming back to the earth. Now, what is happening? Let's say, for example, you are throwing the ball at a velocity of 40 meters per second. Say, for example, you are throwing a ball at a speed of, you are throwing a ball at a velocity of 40 meters per second. So, what is happening? The ball will go to a certain height and then it will come back to the earth with the same velocity. The amount of velocity you throw, it will come back with the same velocity down. Okay, now I told you, I threw. Is it a starting velocity or is it an ending velocity? Is it a starting velocity or is it an ending velocity? Now say, I'm going to throw. Very good. It's a starting velocity. Now, since it is a starting velocity, now think from here to here. Let's say, let's divide this. Throwing up from here to here. Now, if this is a starting velocity, the ball stopped. Can you remember? If a ball is stopping, if an object is at rest, what can you say about the velocity? What can you say about the velocity? Very good. The velocity is equal to 0. Did you understand? The velocity is equal to 0. Now again from 0, it is coming back down to the earth. Now it will, now I told you, if you throw the ball at the same velocity, it will come back to the earth with the same velocity. That means from 0, again it will gain 40 meters per second. Clear with that? Clear with that? So from here to here, this is going to be the starting velocity. This is the ending velocity. From here to here, what is the starting? This person can be the middle person, can be the starting as well as ending. And this is going to be the ending velocity, right? Now what you need to understand over here is, sometimes they can ask a question like this. Now, will it come 40 meters per second? Yes, yes. Velocity, no. I'm talking about velocity, no. Velocity is meters per second. If it is meters per square, it's an acceleration. Did you understand the difference? Okay. Now, guys, tell me, can you remember you studied about? I'll tell you the equation. Now, listen. Now, listen. Now, listen to me. 40 to 0. Now, what is happening? Velocity is increasing or decreasing? 40 to 0. Velocity is increasing or decreasing? Very good. Velocity is decreasing. If the velocity is decreasing, I told a name. What is that name? Very good, Safiullah. That is deceleration. So, what do you need to understand? Whenever an object is against the earth. Now see, the ball is going against the earth. Whenever the ball is against the earth, you will have a deceleration. That means there will be decrease in velocity. Now 0 to 40. What is happening to the velocity? What is happening to the velocity? Velocity is increasing. So if the velocity is increasing, what can you say about? It is an acceleration. It is an acceleration. So that means when the ball is towards the earth, there will be an acceleration. Clear with that? Understood? Got the idea? Got the idea? Right? Okay. Now listen. Now what you need to understand is, now my question is, why did the ball come back? Why did the ball come back to the earth? What's your answer? Okay, you are saying because of what? Because of gravity. Now, who made to fall? Now, who made to fall off the weight? Now, who made to fall off the weight? That is also gravity. Now, listen. Now, due to the gravitational force, the ball came down. So, when the ball came down, what did you form? What did you form? What did you form? Due to the gravitational force, ball came back to the earth. So, you formed acceleration. So, what do you mean by gravitational acceleration? acceleration that is created due to the gravitational force, that you call it as gravitational acceleration. So did you understand what is gravitational acceleration? So when you throw the ball came back to the earth because of what? Because of the gravitational force. So during the gravitational force, what did you form? You form acceleration. So gravitational acceleration means acceleration created due to the gravitational force, that you call it as gravitational acceleration. Did you understand? Clear with that? Got the idea? Yes? So now we understood that when the ball is coming down, it is acceleration, positive or negative? Positive or negative? When there is an acceleration, positive or negative? It's positive, no? Very good. So you will have gravitational force is equals to plus 10 ms minus 2. That means it's an acceleration, no? That's what meters per square. Now, deceleration. What you will have? Gravitational force, the value for the gravitational force will be how much? Minus 10 ms minus 2. So those who told me about minus, you will get an I. Got the idea? Got the idea? Okay. Now I explained you how the question comes. Now, shall we go to the question? Let me give you a sample question. See whether you can do it. Now let's say I am going to tell you, let's say for example, by using the same example. Yes, someone asked me to repeat it. Yeah, listen. Now what you need to understand is, when you throw the ball up, whenever ball is going against, whenever an object is going against the earth, remember there will be a decrease in velocity, which means you call it as deceleration. So now we know that the ball will come back to the earth. Again, I jump and I come back to the earth. What is the reason? Due to the gravitational force. So due to the gravitational force, I come back to the earth. No. So when I come back to the earth, I will be creating an acceleration. So that acceleration, I call it as gravitational acceleration. So what is gravitational acceleration? Acceleration is created due to the gravity. So that you call it as gravitational acceleration. So whenever an object is coming towards the earth, you will gain acceleration. Whenever an object is going against the earth, there will be a deceleration. Right. Now listen. The same example I am going to use and you are going to answer. I think you may have come across with some questions like this. Okay. Now say a boy threw a ball at a velocity of 40 meters per second at a certain height. I'm not asking you to write, just listen. Okay? At a certain height. Velocity is ms minus 1. Acceleration is ms minus 2. Okay, listen. So at a certain height. And the ball came back to the earth. Ball came back to the earth. Now quickly answer and quickly tell me. Due to what reason the ball came back to the earth? Due to what reason the ball came back to the earth? Very good. Due to the gravitational force or gravity. In another term, we can call it as what? Weight. Don't just put as force, it will be wrong. Right. Now, second question. They can ask you, what is the time taken to reach the maximum height? Another question is, they are asking the time with you. What is the maximum time to reach the maximum height? Now to find the time, what is the equation you should use? You have to use the acceleration equation. What is the equation for acceleration? Acceleration is equals to final velocity minus initial velocity divided by time. Now already we know, if that person throws the ball, it will go to the certain height. No, if it goes to a certain height, the ball will stop. If the ball is stopping, the velocity will be 0. No, so in this side final velocity is 0. In this side initial velocity is going to be 0. Then again the ball will come back with the same velocity, which is going to be the final velocity towards the earth. That is going to be 40 meters per second. This should be filled by you. They will only give you one side. The rest has to be filled by you. Right. Now listen. Now, are you going to take the positive side for your calculation? Are you going to take the negative side and struggle? Which side will you be able to take? Which side? Now they're asking time. No, time cannot be negative. Always time has to be positive. Since the time has to be positive, which side are you going to use? I am going to use the positive side. So now tell me, what is my final velocity here? What is my final velocity here? That's 40. What is my initial velocity here? 0. I don't know the time. I don't know the time. But do you know the gravitational acceleration? What is the gravitational acceleration? I told you. What is that? Plus 10 meters per second. So in this case, they will never give you the acceleration. You should already know the acceleration. If you think the question is related to the gravitational acceleration. Now some people can be asked me, teacher, how to know whether it's a gravitational acceleration question? Remember, whenever they say an object is going up, whenever they say an object is coming from up to ground, whenever they say a fruit is going to break from a stalk and coming back to the earth, whenever they say such words like this, remember that is related to the gravitational acceleration question. Clear? Understood? Right. Now how I can find the time? Here put the 10. What I can do is exchange the places. So if you exchange the places, if I exchange the places, 40 minus 0 is 40. 40 divided by 10 is equals to time 4 seconds. That's the answer. That's going to be 4 seconds. In this question, they are in tute. Yeah, in the tute, there are some questions related to that. Clear with that? We will do the questions later after I explain the part. Okay, clear with that? Okay, next thing, the next question they will ask you. Next question they can ask you, find the height that the ball reached to the maximum. Find the height of the ball where the ball reached to the maximum. How can you find the height? In this case only, we will be using linear equation. So what is the linear equation we will be using? We will be using the linear equation. The equation is displacement is equals to final velocity added by the initial velocity divided by time multiplied by 2. So in bracket you have to put. So this is the equation to find the height or distance or displacement. Whenever they give a graph or whenever they ask you the height, you have to use this equation. So how can you find the height of the ball that the ball has been reached? So already final velocity we know. What's the final velocity? That's 40. Initial is 0. What's the time? We already found 4. Do you cut this out? 40 divided by 4, you will have 10. 10 multiplied by 2, you will have how much? You will have 20 meters should be your answer. Your answer should be 20 meters. Clear with that? Got the idea? Wait. There's a small change. Small change. Look here. Displacement is equals to final velocity plus initial velocity multiplied by time divided by 2. I changed and I sorry. So this is the equation. So what is the final velocity? 40 plus 0. Time is 4 divided by 2. Cut this out. If you cut this out 2 times, 40 multiplied by 2 will be 80 meters. So this will be the answer. This is how you find the height of the ball, height of an object, height of the fruit that was there. Clear? Understood? Okay, shall I give a question related to that? Quick question. See whether you can do that. Okay, right. I'll simply give you a boy. I'll just tell you the situation. A boy threw the ball. A boy threw the... no. Don't write. I'll tell you the situation. A fruit was hanging on a stalk. Okay, a fruit was hanging on a stalk. Okay. Then it broke the stalk, fell towards the ground at a velocity of 60 meters per second. Okay. So question number 1. What is the velocity velocity when the fruit was attached to the stroke. Okay. Question number 2. What is the time taken by the fruit to travel to the ground? Okay. Third question. Find the maximum height of the fruit when it was attached to the stalk. When it was attached to the stalk. Quickly update me the answers. Yeah, it is streamed by YouTube. Yeah, you can watch the live stream. No worries. And can you draw the graph for this? Can you draw the graph and see? Can you give a try to draw the graph? Velocity time graph. Draw the velocity time graph for the above incident or situation. Give a try. Let's see whether you can draw the graph. Simply take 2 minutes and finish it out. Don't make it complicated. I think the question is easy. Okay, so if you ask me to discuss, I would discuss. We can move on. Since after that, we are done with that because I have to explain you about the graph only. That's it. 60, yeah? 60 meters per second. 60. I think because of the light. If I keep the light only, it will be visible. Let me take it a bit back. Okay. The last question is draw the velocity versus time graph for the above situation. That's the last question. Some people are asking me what is the displacement? Can we use law of conservation of energy? In this case, you can, but why do you want it to complicate yourself here? Simple, no? Look here. I will quickly tell the answers. Listen. Okay, listen, William. Okay, the first question was what? What is the velocity when the fruit was attached to the straw? The object is at rest. So when the object is at rest, the initial velocity is how much? That's going to be 0. And the second question I asked, what was the second question? Time. So what is our equation? Acceleration is equals to final velocity minus initial velocity divided by time. So what is our final velocity? Our final velocity is 60. Initial is 0. Time don't know. Acceleration, however, 10. So exchange the places. 60 divided by 10. Our answer is 6 seconds. So those who got 2.6 and something wrong, please make sure to correct it. I know some people might not have seen the 60. It might look like 6. Okay, no problem. Right, next one. What is the third one? Third one I told you to find the first answer. This is the first answer. We have 0. Okay, so what is the question number 3? I told you to find the height. How do you find the height? Displacement is equals to final velocity plus initial velocity multiplied by time divided by 2. So since we got this as the answer, 60 plus 0 into 6, then you will get here 2. Then, yeah, gravitational is always 10, na? Then here 3, 60 into 3, 180 meter will be your answer. Okay, so that is your answers to the question. Now, how many of you all drew the velocity versus time graph? Simply tell me. Simply tell me. Increasing velocity or decreasing velocity? Increasing velocity or decreasing velocity? Initially it was 0. When it come back to the earth, it was 60. Increasing, no? So if it is increasing velocity, how many seconds did it take to increase? How many seconds did it take to increase? 6, no? Then simply what should be your graph? What should be your graph? Velocity versus time graph? What should be your graph? What is the maximum velocity it has been traveled? Yes, yeah, velocity. What is the maximum velocity it has been traveled? 60 meters per second. What is the time that has been traveled? 6 seconds. 0. Increase. Clear? Right, simple. So it has increased. So that's how you do it. Right. Now all the part is done. So that's the graph. It has increased. If they tell you if you throw and come back, there is a big graph to do. But usually they will give you a short graph to draw, which you will gain 1 marks. They won't ask you to connect with the graph, no? So this is the way you do it. If they say from 0 to 60, increase or decrease? Increase means going up. Decrease means going down. Did you understand? Increase means going up. Decrease means going down. And also, think like that. 60 is the maximum. 6. They didn't give any other. They didn't give you any other details, no? So this will be the graph. Don't think much. Stress. Reduce the stress. Just think, simple. That's how you have to do. Clear? We can use area also to find the displacement. Yes, you can, but they didn't ask you to do that. But to find the height, you use that equation. But most of the time, they don't ask you to find the area. It's very rare. This time, I'm not very sure that they will ask you regarding the area. It's about the trapezium. It's simple. The same equation comes under that. Right. My video is becoming blurred, is it? Sometimes it might be when I shake here and there, it might be blurred. I'll try to not to shake, okay? Right, okay. Now, we need to understand the connection between displacement versus time graph. And then we have to understand the difference between velocity versus time graph. And then acceleration versus time graph. Acceleration versus time graph. Okay, okay. Now, I will teach you one part. Rest, try to get into your brain. Now, I am going to use the mathematic graph part. Okay. Now, say for example, you have the displacement versus time graph. You have the displacement versus time graph. So, S and T, let me use like that. So, now what is happening is, let's say this is a point and let's say this is also a point. Let's say this is also a point and this is also a point. Now, always remember, the starting displacement, we call it as what? Initial displacement. The ending displacement, we call it as what? We call it as final displacement. Now, the displacement is in y-axis. It is in y-axis. The time is in x-axis. It is in the x-axis. So, this is also we say initial time. And also we can take this as a final time. Now, if I ask you to find the gradient of this graph, how will you find the gradient? What is our equation to find the gradient? y2 minus y1, x2 minus x1. So y2, in science, what is the y2 is representing? Final displacement. Final displacement. So what is the y2 is representing? Final displacement minus, what is y1 here? Initial displacement. The x is representing what? Time. So final displacement minus initial displacement divided by time gives you what? Whose equation is that? Whose equation? Whose equation is that? What are the equations did we study? Whose equations did we learn? We know speed is equals to distance divided by time. We know velocity is equals to final displacement subtracted by initial displacement divided by time. Then acceleration is equals to final velocity minus initial velocity divided by time. Now, whose equation is the displacement versus time graph is talking about? Whose equation? Velocity's equation. So the velocity's equation is being represented by displacement versus time graph. That's what I told you. Whenever they give you the displacement versus time graph in your exam, remember that indirectly they are talking about the velocity. Now think about acceleration. Now let's talk about velocity versus time graph. Let's talk about velocity versus time graph. Now let's say this is velocity here. Velocity versus time graph. Now what is the starting velocity here? Initial velocity, final velocity. Now if I wanted to change the gradient over here, what is the y2 is talking in velocity? Y2 is final velocity, v. Then here, initial velocity. Y1 is talking about initial velocity. So, V minus U, X is representing T. So, automatically, velocity versus time graph is talking about acceleration. Did you understand the connection? Did you understand the connection? Got the idea? All three are interconnected. Okay. My first question from you is, in this lesson, there you have to learn a lot, but I have given you all the things that you have to remember. Now, have you seen graph like this in your MCQs? Have you seen graph like this? Yes, you have seen. Who are these? Who are these graphs? What does this graph is talking about? Who are these graphs and what does this graph is talking about? Listen. Whenever they mention displacement versus time graph num, who is the next graph should be? If you're talking about displacement versus time graph means, whom are you going to talk about? You have to talk about velocity versus time graph. If I ask you about velocity versus time graph means, whom you should talk about? You should talk about acceleration versus time graph. Listen to me. Whenever if you have a graph which is curved and towards upwards, it is increasing. Remember, it is increasing. Whenever you have a graph that is facing downwards, remember that is decreasing. That is decreasing. So simply say, if the displacement is increasing, what will happen to the velocity? Will the velocity increases or will the velocity will not increase? Will velocity increase or will not increase? It will increase. So what will be the graph of velocity? Velocity also will get increased. Now think, if the displacement versus time graph, here displacement is decreasing means what will happen to the velocity? If the displacement is decreasing means what will happen to the velocity? Okay, listen. Some people are asking me to explain again. Okay, I'll teach you something before that. I thought of teaching you in a short way, but let me teach you way. Okay, now in this graph, we are using two strategies. How many strategies are we using? We are using two strategies. So what are those strategies is, strategy number one, we talk about tangents. I think you all know about tangents. So that means you will have a circle. In that circle, you will try to draw some lines and you will try to form angles. No. So in those circles, you will be forming angles. So that is, we call it as tangents. Okay. Second one is, we will call corresponding strategy. Corresponding strategy. So whenever you have a circular curve, you will be using tangents. Whenever you have a straight line, you will be forming corresponding angle. Now, what do you mean by corresponding angle? If I say this is A and if I say this is B, what can you say about the angle A and B? Are they different or are they equal? Are they different or are they equal? Equal, right? Okay, think like that. Corresponding is always, whenever the graph is straight, you will get a corresponding strategy. Whenever your graph is curved, we will be using tangents. I'll teach you how to do that tangents. Now listen to me. Now say you got a graph like this. You have got a graph. In this graph, you have displacement versus time graph. You have displacement versus time graph. So in the displacement versus time graph, they have given you the graph in this way. Now should I use the tangent method or should I use the corresponding method? Everyone will tell me use the tangent method. Now how to do the tangent method is, listen, I will put a point here. Now say this is going to 1 point, this is going to be 1 point, and I'm going to put another point. By using my ruler, I will draw straight to that point, and I will be using my ruler, I will draw straight to my point. Now when I draw straight to my point, am I forming angles over here? Am I forming angles over here? Am I forming angles over here? Yes or no? Am I forming angles? I am forming angles. Now say this is angle number 1 and say this is angle number 2. Now you can see angle number 1 is an acute angle. It is an acute angle that is less than 90. When you look at the angle number 2, it's a right angle which is exactly 90. Okay. Now when you talk about the angle from angle 1 to angle 2, is it increasing or decreasing? Is it increasing or decreasing? Is it increasing or decreasing? Increasing, no. If the angle is increasing, the gradient also will increase. If the gradient is increasing, the displacement also increasing. So we know the displacement versus time graph gives us the velocity. So when you look into that, velocity also increasing. Now think, now they have given a picture like this and they are asking you to underline what would be the velocity versus time graph. So velocity versus time graph, should it be like this or should it be in this way or should it be like this or should it be in this way? Now MCQ, I have given you MCQ. Quickly tell me. This, remember, going up is increasing, positive way. Going down, decreasing, negative way. Constant, constant. Positive constant, negative constant. What is the answer? Answer is first one. Clear the got it how to do your MCQs whenever you got a graph like this? Okay. So now this is the first option. Now let me use another one. Let me use another one. Let's see whether you get it properly. Now say for example, they have given you velocity versus time graph. So they have given you velocity versus time graph like this. By looking at that, now tell me, now should I use the tangent method over here or should I use the tangent method or should I use the corresponding method here? Very good, corresponding. Now if I use the corresponding method here, if I draw some lines, I will be forming angles. Simply, I can say angles are equal. Angles are equal. That means there is no change in the angles, there is a equal. So if the angle is equal, gradient also will be equal. If the gradient is equal, velocity will be equal. Automatically, when the velocity is equal, that means they are moving at what? Uniform velocity. That uniform only we call it as equal. Did you understand? That uniform. So if you have a uniform velocity, what can you say about the acceleration? Acceleration also will be uniform. Acceleration also will be uniform. So is it moving in a positive way? Is it moving in a negative way? Positive or the negative? Up is positive or negative? Positive. So that means acceleration, positive, uniform. Now tell me which will be the graph of the acceleration. Should it be up or should it be down or should it be straight, positive or should it be negative, straight? What will be the graph? Number 1, number 2, number 3, number 4. Which one will be the graph of the acceleration? Think. Number 1 is moving up, okay? Number 1 is moving up, increasing. Those people are increasing. These people, decreasing. These people, uniform. Uniform shows straight. This one, negative uniform. Negative. See, positive uniform. Now what should be your answer? Your answer is third one. Your answer is third one. Clear with that? Your answer is third one. How in the sense? Look here. Your angle is uniform, no? This shows increasing, no? Now I am asking you, is the acceleration increasing? Is the acceleration is increasing? No, right? So can it be option number 1? Can it be option number 1? No. It cannot be option number 1. It only indicates the uniform. The straight line says equal. Equal. Did you understand? Equal. The straight line shows we are moving in an equal velocity. Clear with that? Got the idea? Understood? Okay. Let me give you another one. Now say for example, now they have given you something like this. Okay. They have given you displacement versus time graph. Mehammer. They have given you like that, downwards. Now, if it is downwards, automatically we know that now initially when it was facing upwards, it is increasing. No, we got the idea, it is increasing. What will be the opposite? What will be the opposite? If this is increasing, this one will be the decreasing. So if this is decreasing means the velocity also will be decreasing. No, what will be the graph of the velocity? What will be the graph? First one or second one or third one or the fourth one? Number 1, number 2, number 3, number 4. Which one? Number 2. Very good. Understood. Okay. Last one. Okay. Now last one. Listen. Now listen. The last one says that, now say for example, right, good. Now say for example, they have given you something like this. Velocity versus time graph is given in this way. Now they're asking you to find the acceleration. Now, what are the two strategies I told you? Okay, ma. What are the two strategies I told you? I told you one is tangent strategy. That is whenever you get a curve. Other one I told you that corresponding strategy. Do you think I can form an angle in this? Can I form angle here? Can I form any angles here? Now, if the velocity is uniform, can I form any angles? Now think, if it is straight, other than I told you, any other strategies, is any of these strategies are suiting? Is it suiting? No, right? That means, will you have any angles? Will you have any angles? Zero angles. You will have zero angles. So if you have zero angles now, what do you think? There is no gradient. There is no velocity. If the velocity is zero, what can you say about the acceleration? Acceleration also will be zero. So what will be the graph? Graph is empty. Graph is empty. There is nothing. You have to just draw the graph and show graph is empty. Clear with that? Clear with that? Got the idea? So we understood that the graph is empty. Clear? Got it? Understood? Listen. Now, whenever you see a straight line like this, straight, whenever velocity is uniform, can you form any angles? Can you form any angles? Other than the strategies I told you. Now see, tangents, there should be a curve. Do you have a curve? No. Do you have a corresponding side? Do you have like corresponding angle? No, you don't have. Now tell me, can you form any angles? Can you form any angles over here? There's no way of forming any angles other than the strategies I told you. You can't form any angles right now because these two strategies only you can use. Other than that, did I tell you anything else? Did I tell you anything else? No. Just understand, whenever velocity is uniform, the angle will be zero. If the angle is zero, gradient also will be zero. If the gradient is zero, velocity will be zero. So we know velocity versus time graph gives you acceleration. Then the acceleration also will be zero. So therefore the acceleration will be, blank. The graph will be blank. Clear with that? Clear with that? Got the idea? Okay. I hope the graph part I have given my maximum to you. Clear? So tangent means increasing, corresponding means decreasing. No, Yahan, it's not like that. Tangent means, listen, this chapter is over. Now listen, tangent means whenever you get a graph curved, remember if it is facing this way, it is increasing. Whenever you get a graph like this, opposite way, that is decreasing towards down. This is towards up. Clear? Corresponding means what? You have corresponding angle. So you create angle, corresponding angle. Whenever you have a straight line or when you have something like this, you will form a corresponding angle. Clear with that? Got the idea? Right. Now let's go to the Newton's law of motion. Now you say, this lesson is easy. No, no, no. Not lesson is not easy. That means this lesson you have so much things to learn. Okay, since you by heart the all three laws, that means you don't know what is hidden inside. Okay, so let's learn Newton's law of motion connected with the frictional force. Right? Okay, like that we will start completing the lessons and we will come. No hurry, patience. We can move on. Right? Okay. How will the acceleration graph when decreasing? Now, when you talk about acceleration, how will be the acceleration graph when decreasing? You mean Saliha, it's like this. If you ask me in this, if it is like that, you're asking me. What time class finishing? Yeah, we are going to the new chapter. Let me know, Saliha. Okay. Okay. Now see, say velocity versus time graph, they have given like this. It is facing downwards. If it is facing downwards, means velocity increasing or decreasing? Velocity is decreasing. If the velocity is decreasing, what will be the graph? Will it be graph number 1, or will it be graph number 2, or will it be graph number 3, or will it be graph number 4? So this shows increasing, this shows decreasing, uniform positive, uniform negative. So which one will be the graph, Saliha? Graph number 2. Clear? Simple? Okay, right. Let's not stick into this and we'll move on. That's not really needed, Seema. Okay, right. They do not ask big questions like that. The miscellaneous is like, what do you say? Miscellaneous is something like, it's in detail. If you are doing unit test, whenever you're doing unit test or term papers, then miscellaneous exercise questions will be suitable. But since you're doing O level, this lesson only graphs some equations. If you know, that's enough, because this lesson is not important. There are lessons for you to get important and to focus a lot. There are. So if we stick on the same lesson forever, we have to do that only. So let's move on. Okay. Right. If there's any doubt, you can contact me. I will tell you. I will explain you in a call or whatever. Right? Okay. Right. Listen. Now let's talk about Newton's law of motion. Now, before that, before we study about Newton's law of motion, how did this lesson come from? Can you remember in grade 9 you studied about force? You studied about force. Now, if I take an object, I should move this object. What should I do if I want to move this object? I should either push this object or I should either pull this object. So that we call it as what? Force. So the scientist who discovered the force was whom? Isaac Newton. So is it Azan? Is it Azan? I'm unaware about it. I will provide break. Don't worry. Don't worry. No, it's not Azan. It's in some places it's Azan. Right. Let's wait for 2 minutes. No worries. Let's wait for 2 minutes. Okay. Let's wait for 2 to 3 minutes. Once it's done, let me know. Okay. Yes, I'm recording this session.
Okay, so it's over.
Right. Okay. With this lesson, I will be finishing the lesson resultant force. Okay. So Newton's law of motion, resultant force, frictional force, all of them I'll connect together and I'll be teaching you. Then we can easily go to the important lesson, chapter 12 and chapter 11. Turning effect of a force, equilibrium of force. Those lessons are little important. Okay. Right. Okay. Now listen. So now what is happening? So the scientist who discovered force is Isaac Newton. So Isaac Newton is the person who introduced the Newton's law of motion. So if I need to move the object to the north, what should I do? What should I do? Now say I want to move this object to the north. So I have to push the object to the north. So now think about force. Now already I taught you force is a vector quantity or a scalar quantity. Vector quantity or a scalar quantity. Does a force has a magnitude? Does it has a magnitude? Say for example, I am pushing this object with a 50 Newton. So now that means this object is moving towards which direction? It is moving towards the west. So the object is moving towards the west and I told you 50 Newton. So there is a magnitude and there is a direction. So when there is a magnitude and there is a direction, what can you say? This force is a vector quantity. Clear? So what is the standard international unit you measure force? That is Newton. So the standard international unit that you measure force is what? Newton. So now if I ask you a question, say for example, now you have an object. Now say for example, you have an object. I'm talking about the resultant force here. I'm connecting the lesson resultant force, so it will be easy for you to do some questions related to the forces also, because I will give you questions. Second chapter of your grade 10 will be connected with this lesson, so I will give you questions related to that. Scalar quantity means a quantity which has no direction but has a magnitude. Okay. Now listen. You have an object. Okay. Now say for example, you are pushing this object towards this particular direction. So you are pushing this object for 20 Newton. You are pushing it in 20 Newton in this particular direction. So you want it, now say you want to move it more faster. So what are you doing? You are calling your friend to move this object. So she or he also will come and move. Now say you are giving 20 Newton. Your friend is also giving 20 Newton. Now say for example, now what is happening? Will this object will be faster or slower than earlier? Now your friend also joined. When your friend also joined, now this object will be faster or slower than earlier. It will be faster than earlier. Now what you need to understand? Now what has happened to the force? Is it increased or decreased? Initially it was 20. Now you called your friend. It has become 40. That means the force has increased. So what did you understand? How did you understand the force has increased? Why did I say it is 40? What is the reason I told 40? Because did you subtract the value or did you add the value? Did you subtract the value or did you add the value? I added. Why did I add? Me and my friend, are we pushing this object towards the same direction or are we pushing towards the different direction? Same or different? Same direction. So whenever an object a push, now say for example, whenever an object is pushed towards the same direction with multiple forces, you have to add. Whenever an object is pulled at a different direction or pushed at a different direction by multiple forces, you have to subtract. So subtraction or addition of multiple forces according to the direction, we call that as resultant force. We call that as what? Resultant force. Now you know what? Some people, they make mistakes. Mistakes like what? Now say for example, I'm asking, okay, how are you moving? I'm asking, let's say, how does an object is moving? How is the object is moving? You will say, object is moving because of the force. Wrong. Your answer is wrong. Remember, object always moves with the resultant force. So some people are asking me the definition. You don't need to know the definition, but I'll tell you the definition one more time. Listen to me. Two or more forces that is indicated by single force, two or more forces that is indicated by single force that you call it as resultant force. So two or more forces, if it is being indicated by one single force, that you call it as what? Resultant force. So if they ask in exam how an object is moving, is it because of force or is it because of resultant force? Your answer should be resultant force. Now say, I gave a force. Did it move? I gave a force. Did it move? No. But I'm giving a force which is giving a final result of moving. That you call it as resultant force. So resultant force means a force that helps an object to move. That force only we call it as resultant force. So there are situation. I am pushing this car. If the car is moving, no, I'm calling my dog, I'm calling my cat, I'm calling my friend. Let's push the car. Now what is happening? All of us, all the forces coming together and making it as one single force in order to move the car, that we call it as resultant force. So an object is used to move by using the resultant. Clear with that? Understood that? Got the idea? Yeah, I just told cat can't push. However, right. Now listen. Now what is happening? Have you played tug rope with your friends? Tug rope, say you are here, even though with a shawl or whatever, the rope. Now what will happen? Now what will happen is your friend is pulling from other side, your other friend is, that means you are pulling from this side, your other friend is pulling from the other side. Now say you are pulling 50 Newton here, he is also pulling 50 Newton. Both of you all are pulling with the same magnitude in opposite direction. Should it be subtracted or should it be added? Opposite direction. Addition or subtraction to find the resultant force. So the resultant force will be subtraction since you are in opposite direction. 50 minus 50 is equals to 0. What can you say about the object? If you don't have the resultant force, will the object move? Will you move? No, it is at equilibrium. It is at equilibrium. You are at rest. So same thing. When I come to the frictional force, I will ask the same question. Please remember this and tell me. Okay? Right. Now listen. Resultant force is done. We are done with the resultant force. Now we need to study about Newton's law. Now, when we talk about Newton's law, I will use so many examples. Let's see whether you understand. Because some of you all by heart what is there in your book. But I can tell you a easiest way to remember the Newton's law of motions and all. There are several Newton's law. We'll study the three. Okay. Now what happened? Isaac Newton. How did he make these laws? Now one day, you know the story. He was sleeping under the apple tree. Now suddenly what happened? Suddenly what happened? One apple fell on his head. One apple fell on his head. Okay, now what is happening? Someone asking about resultant force. Guys, give me a second. Shada, listen. Now, when you have an object, now say you and your friend is pushing the object. Say if you are pushing with 20 Newton, your friend is also pushing with 20 Newton. Whenever the force is in same direction, what can be our resultant force? Our resultant force will be added. It will be added. 20 plus 20 will be 40 Newton. Towards which direction? Don't forget to mention the direction whenever you are talking about the resultant force. Okay. Now let's say, for example, another example. Imagine here 50 Newton. And here also, let's say, for example, this side is 20 Newton. Now see, both the side is different with magnitude and different in direction. So should I add or subtract? I have to subtract. So 50 minus 20. So what is my answer? 30 Newton. That means which side the object will move? Is the highest force or with the lowest force? The highest force. So it will move towards this direction. So always you have to mark the this direction. Clear with that? Always the resultant force will be connected with your middle of your questions. Okay, right. Now let's talk about the Newton's law of motion. So what happened? So one day he was sleeping under the apple tree. Suddenly one apple came and fall onto his head. By keeping that incident, what did he do? Equilibrium means equal, darling. Right. Equal. We say equilibrium is equal. Okay. Now what happens? That fell on his head. Now what happened? Once the apple fell onto his head, By keeping that situation, he created three main laws of Newton. Now what happened? Same, listen. Chapter 2 is getting connected. Listen, chapter 2 is connected. Now, initially, the apple was fixed to the stalk. Initially, the apple was fixed to the stalk. Now, when the apple is fixed to the tree or the stalk, was this apple is moving? My question, was this apple is moving? Yes or no? Was this apple is moving? No. If the apple is not moving, we say apple is at rest. If the apple is at rest, I told you if the object is at rest, what can you say about the resultant force? If you have resultant force only, you can move. If the object is at rest, remember what can be the resultant force? Your answer? What's the answer for the resultant force? Very good. That is zero. The resultant force is zero. Remember the tug rope incident. What happened? You and your friend pulled with the same magnitude. What happened? You both didn't move. You both with the same magnitude. It was zero. So there was no movement. So whenever you say when an object is at rest, resultant force is zero. So now the apple attached to the tree. What can you say about the resultant force? Zero. Okay. Now think like this. Now when you have an object, okay. Now whenever you have an object, tell me, will you? Is the object is against the earth or is it towards the earth? Is it against the earth or towards the earth? Now say when you have an object from the center of the object, what is the force that is being spreaded from the center of the object? From the center of the object, what is the force that is acting towards the center of the earth? Very good. Weight. So from the center of the object towards the center of the earth, you can have gravity or you can have the weight. You can have the weight. Okay. So weight is acting downwards, so the stroke acting upwards. The stroke is acting upwards. Now see, think about the tug rope. I also was pulling. My friend also was pulling. Now what happened? Towards the center of the earth, I have a force, and there should be another force that should act opposite to the weight, that we call it as tension. So in this situation, we have tension and we have weight. So when we have both of these forces, we got the resultant force as zero. Why? If the tension is 50 Newton means the weight might be 50 Newton. So that's the reason the resultant force was zero. Clear with that? Got the idea? So we need to understand the tension and the weight. Are they equal here? Yes. Got the idea? So this is the Newton's first law. Listen. Now say, the first law is until an unbalanced force. Tension means the opposite force whenever an object is hanging. Whenever an object is hanging, from the center of that object, there will be a force towards the earth, towards the center of the earth. We call that as weight. No, think about the bulb at your home. Is the bulb is moving always like a ding dong bell? No, right? So what is it happening? It is at the rest. So when the object is hanging opposite to the weight, there will be another force that makes this object to be rest. We call that as tension. Clear? Got it? Now listen. Now what is the Newton's first law? Say, Newton's first law is what is happening? Now say, until an unbalanced force. Perpendicular reaction is different, darling. Tension is different. Perpendicular reaction, we call it as normal reaction in another term. When you study frictional force, you will learn. Okay? Now listen. Now what is happening? Until an unbalanced force. Now another name for the resultant force, I call it as unbalanced. See, unbalanced, not balanced. Unbalanced force. Resultant force. Both of these names are same. So until an unbalanced force acting on an object. Now say, now until an unbalanced force means until you give a force to this object. Is this object is moving? Look at the word. They said until. Until means what? Until you give a force to this object. Is this object is moving? Is this object is moving? No. the object at rest will remain stationary or it will remain at rest. Clear? That is the first part of your Newton's first law. So what is the Newton's first law is saying? Until an unbalanced force acting on an object, the object at rest will remain stationary or the object at rest will remain rest. Okay, now listen, the next part. There is another part in this. There is another part. Listen. Now let me use the normal life example. Has anyone gone in bus trip with your family? Cool. I think everyone must have gone through the bus. Anyways, any one day. Once in a lifetime. Okay, listen. Now say you are standing in the bus. Say you are standing in the bus. Okay, so you are standing inside the bus and the bus is at rest. The bus is at rest. Now, do you have any force acting in this direction? Now, say for example, when the bus is at rest. Now imagine, now bus is at rest. Now imagine the bus is starting to move. And it needs to start in this particular direction. Say for example, it is going to move in this particular direction. Okay. Now, if the bus is moving in this direction means your body also will be moving at what direction? If it is moving towards the east means your body also should move at what? Towards the east. Right. Now listen. Now my question is, tell me which part of your body is in contact with the bus? Head or leg? Head or leg? Very good. Leg. Now, if the bus is moving in this particular direction, okay, and the leg also in this particular direction, leg also will be moving with the particular direction. Okay. Now say you are standing here and in front of you, some people are pulling your legs. Now say for example, some people are pulling your legs. And what will happen? Now what will happen? Now say for example, let's say for example, let me use this. Now say you are moving like this. When you are moving, no, I'll use this direction itself. You are moving like this. Okay. So when you are moving in this way, okay, when you are moving in this way, now your legs also moving in this particular direction. Now what will happen? If someone is pulling you from front, what will happen to your body? Will you go back or will you go front? Suddenly the person is pulling. Think our Colombo bus, no? How? Suddenly he will take off the bus without even telling us. Sometimes our head also will go back. Only our leg will come front. So now what happens? Our leg will move in a particular direction of the bus while our body will go back. Did you understand? Now think, you are a big person, no? You don't hold the bar, you don't hold the seat, you just stand. Suddenly bus start to move. In which direction will you move? If the bus suddenly start, now say you are standing like this, suddenly bus start, you will go back. Did you understand? And suddenly you will go back and come front. Sometimes when you apply brake, you will give a balti and you will come out of the bus and stand. So that kind of bus only we usually go in that. No? We will go back and then again we will come front. Did you understand? We'll go back and then we will come front. Got the idea? Understood? Right. Now say for example, now inside the bus, you are steady inside the bus and the bus is also moving in this particular direction and then you are also moving in this particular direction. Yeah, especially red bus. Okay, now listen. Now your body is also moving, bus also moving in this particular direction. Suddenly your friend came in front of the bus. Suddenly your friend came in front of your bus. Now just imagine, your friend came in front of the bus. What should the driver do? Should he kill your friend and go? Should he apply brake? Okay, he should apply brake. So if he wants to apply brake, which means the tire should apply a force, no? Should it apply a force towards the west or should it apply a force towards the east? Kill or save? You need to save, which means it should be opposite to the direction. That means if the bus is moving in this particular direction, the brake should be given at the opposite direction. Clear with that? Got the idea? So when the driver gives the brake, what will happen? Suddenly you also will start to go backwards. Clear with that? Understood that? Okay. Now let's talk about the carom. Let's talk about the carom. Say you have the carom disc. Until you give a force, the carom will be at rest. Once you give a hit, what will happen to the carom? The carom will keep on, the carom disc will keep on moving with a uniform velocity. So what is our Newton's first law? Until an unbalanced force acting on an object, the object will remain rest. The object in motion will move with a uniform velocity. So that is the first law of Newton. So that is the Newton's first law. Clear with that? Got the idea? So that's what they say. What is the reason they ask you to wear seat belts? You will go back suddenly, no? That's the reason. You will go front, come back. Sometimes you will go back, come front. So there are situations like that. Sometimes your rib can hurt. Your rib can hurt. Now, when you talk about your rib, now say you are the driver. Suddenly, when you apply brake, you will go back, come forward with a uniform velocity. Sometimes your rib cage can go and get hurt with the steering wheel. Now, what will happen? Steering wheel is also very powerful. Sometimes your rib cage can break. Clear with that? So that's the reason some airbags come. Sometimes you have some seat belts to wear. That is the main reason. That is according to the Newton's first law. Clear? Understood? So did you understand what is Newton's first law? So say it with me. What is Newton's first law? Until an unbalanced force is acting on an object, the object at rest will remain at rest. Those in motion moves with a uniform velocity. Clear with that? Got the idea? Understood? So if they ask you an example for the Newton's first law, say carrom. Playing carrom is according to the Newton's first law. Okay, until an unbalanced force acting on an object, the object at rest will remain rest, comma, those in motion will move with uniform velocity. Those in motion will move with uniform velocity. Now let's go to the Newton's second law. Now according to the, I'll again repeat one more time. Until an unbalanced force acting on an object, the object at rest will remain rest, comma, those in motion will move with a uniform velocity. 12 Akmal. Right. Okay. Let's talk about Newton's second law. So when you talk about Newton's second law, what do you understand by the Newton's second law is, now according to the first law, what was the first law? Initially, the apple was fixed to the tree. Now the Newton's second law is the apple broke the stroke. According to the Newton's second law, the apple suddenly broke the stroke. That means suddenly the stroke broken, and what will happen to the tension? Now if you have any object hanging, you will have a tension. Now what happens? Suddenly the rope or the stroke is broken. Will you have tension anymore? Will you have tension anymore? Say for example, from the center of the object towards the center of the earth, you are having weight. Say weight is 50 Newton. Say tension is 50 Newton. Now the tension is gone. The only force, what is there? Weight. Will you have a motion there? Will you have a motion? So there is no tension. Will you be at rest? Will you be at rest? No. So what will happen? The weight in downwards, the apple will start to fall towards the earth. Clear with that? Clear with that? So now what will happen? The resultant force will be equals to 50 Newton. Since there is 0 over here and there is a 50. So the resultant force will be towards the earth, and you will be having what? You will be having 50 Newton. Now can you remember in Newton's first law I told you, if the object in motion, they will move with the uniform velocity. Now once the apple is broken from the stroke, what will happen? Can you remember, whenever an object is coming towards the earth, Will you have acceleration or will you have deceleration? Whenever an object is coming towards the earth, will you have acceleration or will you have deceleration? So that means Newton's second law is talking about acceleration. Why acceleration? Because when the velocity is increasing, what will happen to the acceleration? There you will find the acceleration. Clear with that? Clear with that? Initially the velocity was 0, then velocity gained, and there was increase in velocity, you got acceleration. So now what happened? Do you have a resultant force right now? Do you have a resultant force right now? Yes or no? Initially it was the word no resultant force. It was 0 until. Now, do you have resultant force? Do you have resultant force? Yes. Which you call it as unbalanced force. So what is our second Newton's law? When an unbalanced force acting on an object. Now who is that? Acceleration is directly proportional to the force and inversely proportional to the mass. Inversely proportional to the mass. Clear with that? Clear with that? So, what did they say? When an unbalanced force acting on an object, acceleration is directly proportional to the force and inversely proportional to the mass. So you know directly proportional means they are equal like that. And then they are inversely proportional to the mass. Now in this second law only, you are forming an equation. Acceleration is directly proportional to the force and inversely proportional to the mass. No. So what are we going to do is, we call this sign. What do we call this sign as? Do you know what is this sign we call it as? We call this as proportional. We call this as what? Proportional sign. So if I want to remove this proportional sign, I have to add a constant. Constant means I have to add a simple letter, constant. Now what will I do? I will have A, K, F over M. Now this constant will be turned as an equal sign. It will be turned as an equal sign. That means I say acceleration is equals to force over mass. Now what I can do here is, I can take the mass to the other side, which means mass under division. If you take to the other side, it comes as a multiplication. That is equals to force. So therefore, what is the equation for the force? Force is equal to mass into acceleration. So what is the unit you measure force? Newtons. In another way, mass kilogram, acceleration meters per square. So kilogram meters per square also we can use as a unit to measure the force. But I would recommend better to use the Newton. Better to use the Newton. Right. That is second law of Newton. Clear with the second law? Am I going too fast? Right. Everyone understood? Right. Now let's go to the third law. Let's go to the third law. Now when you talk about the third law, what do you need to understand is, give me a second. I missed a message. Okay, who didn't understand? Okay, they are saying that now initially proportional means they comes as a equal. Proportional means they are directly proportional. If acceleration increases, if the acceleration increases, the force also will increase. That means if these set of people increasing, the opposite will decrease. So this is how we call it as proportional. We have already studied in maths proportional. Can't you remember? So we call this as proportional. So what is the second law? When an unbalanced force acting on an object, when an unbalanced force acting on an object, the acceleration is directly proportional to the force and inversely proportional to the mass. Simple. Third law. Everyone knows the third law. What is that? Every action has equal and opposite reaction. You know why do we say opposite reaction? Every action has equal and opposite reaction. Mariam, whenever they talk about related to the acceleration, a car, let's say a car traveled at a highest velocity. Whenever they say like that, it is related to the acceleration. No? So that is related to the second law, Newton's second law. Right. Now think about, yes, the Newton's third law is like karma. Let's talk about. Now say, mostly boys knows this. Now say I want to punch one person. So you will be bend your knuckles like this, and you have seen whenever you hit on the table, say you got angry, you hit on the table. Suddenly you will feel pain on your knuckles because I hit the table. Why did I feel pain on my knuckles? You remember, whenever you hit the table with 50 Newton, the table also will give you the same force that you hit with the 50 Newton. That's the reason what will happen. I will tell you us. Okay. So what will happen? Your knuckles will start getting red. Clear with that? Got the idea? So every action has the equal and opposite reaction. So rocket, what will it do? Rocket will hit the ground and it will go up. Like that. When you walk, what do? When you walk, you will hit the ground and then he will walk. Second law, I told you, most of the time, second law, they will be talking about velocity and they will be talking about acceleration. Okay, what is second law? When an unbalanced force acting on an object, acceleration is directly proportional. Acceleration is directly proportional to the force and inversely proportional to the mass. And inversely proportional to the mass. Clear? Okay, shall I give you a kind of a question? See whether you can do it. It is related to the Newton's law. Usually Newton's law, you will have this kind of questions. See, an object, I'm just giving you, an object of mass 5 kilogram pushed in both sides. Find the acceleration of the object. So they have given a picture to you like this. Say for example, okay, right. Can you find the answer for this quickly? This is related to the whatever I taught you right now. Think well. Second chapter is connected. Chapter 9 is connected. Chapter 3 is connected. Think well. Think well. They are asking the acceleration, not the force. Think well and answer me. Atik, I'll explain you regarding that. I'll explain you regarding the moon. It is there in this lesson. No worries. Okay, listen. Now, most of the time we do a mistake. What is the mistake is, can you see, I taught you resultant force. So when I have taught you resultant force, what is your first equation? Now, since they have asked you to find the acceleration is given, mass is given, they have given you the mass, they have given you the acceleration. Okay. So now think, what is the equation? 12 now. Force is equals to mass into acceleration. First of all, if they have given you mass, okay, mass is given, that is 5. Acceleration, don't know. What is the force? By using the resultant force, can't you find the force? 120. Both of them opposite direction. So 100 subtracted by 20 is 80. So that means you take the 80 to this side, 5 to the other side. 80 divided by 5 is equals to acceleration, which means it's going to be 16 meters per square. This should be your answer. Clear with that? Clear with that? Got the idea? Okay, shall I give you another question to give a try? Okay, so this is a different one. See whether you can find it. This is related to the second chapter and your fourth chapter. Okay, listen. Let's say an object Sukaina, you asking me to explain that question again? Right, listen. Now, I told you that what was the question? Here you had an object. This object is 5 kilogram, and this object is pushed from the both the sides, that is 100 Newton, and this is 20 Newton. Okay. And initially they are asking you to find the acceleration. Now already I explained you the equation to find the acceleration. No. Can I use this equation, acceleration equals to final velocity minus initial velocity divided by time? Or can I use this equation, force is equals to mass into acceleration? Which equation can I use, Sukaina? Is it equation number 1 or equation number 2? I have to use the equation number 2 no. So if I use the equation number 2, mass is already given. Force, how can you find the force? Already they have given you two forces, which means you have to find the resultant force. So this is at the opposite direction. Or since this is opposite direction, 120 has to get subtracted. That is resultant force. So when you subtract, you get the answer as 80 Newton will be a force. So 80 equals to 5 multiplied by A. So then 5 take to the other side, make the A as a subject formula. So 80 divided by 5 is equals to 16 meters per square. So which comes as the acceleration. Clear? Got the idea? Okay, right. I will give the break by 8:30. Okay? 8:30. So you all can go and pray. Right. Now what is the next thing is, let me give a question. Say for example, they have given an object moves. Now this is related. See, finishes at 12. Okay. Tomorrow we have the biology. I will update you all the tunes. Okay. Okay. Right. An object moves at a velocity of 10 meters per second, and increasing up to it's a free tute. No, you can get the PDF. Increasing up to 20 meters per second in 2 seconds. Okay. Then the mass of the object is 5 kilogram. I have just given you. Find the force applied. Find the force applied. Can you give a try? Now the question is to find the force. Question is to find the force. Okay. Few people think well. Second lesson connected. Fourth lesson connected. Okay, I will explain, think well and answer. Listen. Okay, listen. Now, what is our equation to find the force? Force is always, remember, write the equation. Whenever you write the equation, your answers will be correct. Listen. Force is equals to mass into acceleration. Now, did they give you the mass? Yes, mass is given, 5. Have they given you the force? No, you had to find the force. Have they given you the acceleration? No, acceleration is not given. So what is the equation to find the acceleration? The only option is acceleration equals to final velocity minus initial velocity divided by time. So they said that an object moves at a velocity of 10 meters per second and increasing up to 20 meters per second in 2 seconds. No, it is 2 seconds. 2 seconds, not 25. It is 2 seconds. Okay. Now what you need to understand is, what is our final velocity? Final velocity is 20. Initial is 10 divided by 2. 10 minus 20 minus 10 is 10. 10 divided by 2 is 2. Clear there? 20 minus 10 is 10. 10 divided by 2 is 5. No, it will be 5. Now what is happening? Now you will write 5 here equals to mass, that is also going to be 5 multiplied by 8. So now what is going to happen? You will exchange the places, no? So you will be exchanging the places. So since you have to explain, now wait, you have the force 5, you have the mass here. So now what will happen? A, what do you mean by A is 5? Yeah, you have to find the force, no? Sorry. We all made a mistake. Listen, I already found the acceleration, which is 5 meters per square. So what is the mass? Mass is 5. Okay. And then acceleration is 5. So 5 into 5, your answer 25 Newton. Clear? Understood? Got the idea? The answer is 25 Newton. So little down benama, doom benama. Right. Let's go to the momentum. And someone asked me regarding the moon. So some moon questions also will come. I will explain you again how did it come. The reason is they're asking you to find the force. No, if they have asked you to find the force, you have to find the acceleration. Already they have given you the velocity. So velocity final and initial divided by 2, you get the answer as 5. So acceleration will be 5, mass also will be 5. 5 into 5 is 25. That's how I got it. Now let's talk about momentum. Is very simple. How difficult it is to stop a moving object. We call it as what? Momentum. Say you have a rubber ball. You have a rubber ball. And you have a leather ball. Now which ball will be very hard to stop? Rubber ball is easy or leather ball? Which ball is easy? Now think about the toy car. Let's talk about the toy car and the real car. Which car will be easy to stop? The toy car will be easy to stop. Rubber ball will be easy to stop. But the leather ball, the real car will be hard to stop. So when you talk about momentum, we say how difficult it is to stop a moving object. We call it as momentum. So normally momentum comes with the equation of what? Momentum is equals to mass into velocity. So this is the equation. If you know the equation, mostly, rarely you get the question related to the momentum. So momentum will be what? Moment. Moment of force is different. Momentum is different. Moment is different. So mass into velocity will be what? Momentum. So kilogram into meters per second will be the equation. So kilogram meters per second will be the equation for the momentum. Right. Okay. Let's talk about the moon. So most of us going a problem with the moon, right? Now let's say for example, now we already know what is gravity. No, we know what is gravity. We know center of the earth is pulling all of us towards the center of the earth. Now we know the force that is attract. Is there any unit for momentum? Yes, kilogram meters per second. This is the unit for the momentum. Okay. Now what is happening is, are you falling from the earth or are you on the earth? Are you falling from the earth or are you on the earth? We all of us are on the earth because every object is pulled towards the earth by the center of the earth. That we call it as what? Weight or gravitational force or gravity. We call any of them. And I already told you what is the equation to find the weight. Weight is equals to mass into gravitational force. So what is the gravity on the earth? That is 10 meters per square. So that is how we calculate. Now when you talk about moon, can astronaut keep their leg on the moon? Can the astronaut can keep their leg on the moon? Do they go to the moon or do they float in the moon? Do they float in the moon or do they like walk like us in the moon? They usually float. So you will also have a weight on the moon. Will it be stronger or will it be lighter? Now we already know that if something is floating, that means what can you say about the density? The density will be lighter. So same like that, on the earth, we are sinking on the earth. When we are sinking, what can you say about the density? The density is very high. Okay, so the weight on the moon is lower than the weight on the earth. We need to understand. So we know the equation for the weight is mass into gravitational force. And my question here is, now what is the difference from earth to the moon? What is the difference? Now say for example, on the earth, my body mass is 60 kilogram. My body mass is 60 kilogram. After I go to the moon, will I become like 50 kilogram? Will I lose 10 kilogram there? Yes or no? I will not. But what is changing over there? What is changing? Will the gravitational force will be same like the earth on the moon? Will it be same? No. The gravitational force is changing. The fact that, what is the fact that is changing over here? The gravitational force. So when the gravitational force is changing, the weight also will be changing on the moon. Clear with that? Clear with that? So every year you get only one question related to this. That is, they are saying that 1/6 of the weight will be reduced when you go to the moon. That means 1/6 of the weight will feel like you are reduced when it comes to the moon. That means 6 times less than the earth. The moon will have the weight. Let's say, for example, a 60 kilogram man is going to the moon. So now what is the weight of this moon? Sorry, what is the weight of this person? Weight is equals to 60 multiplied by 10, 600 Newton. A 600 Newton person is going to the moon. What will be the weight of this person when he go to the moon? How can we calculate? We will take it as 1/6. 1/6 means what? We will take 1/6 into 600. So 6 cancel out. What will be the weight of the person on the moon? 100 Newton. So this is the most important and most asked question in your exam. They do not go apart from 60. 60 is like a common word, right? So he will become 10 kg. No. It's not like that. I'm telling you that a person will not change his mass wherever he go. The only thing that is changing is gravity. From earth to the moon, the biggest difference is what? Gravity. Did you understand? From the earth to the moon is what? The gravity is changing. Now say for example, a person who is 60 kilogram in the earth. Listen, the person who is 60 kilogram in the earth is going to the moon. So suppose, what is his weight on the earth? What is his weight on the earth? Listen to me. What is his... Listen. Now, just be calm and listen. Now, on the earth, we all walk on the earth because gravity is high or gravity is less. Because the gravity is high or because the gravity is less, we are on the earth because of the gravity is high. Now, the same person who is 60 kilogram, if he go to the moon, he start floating. No, he can't be on the earth. Sorry, he can't be on the moon. He can't keep his leg on the moon, but he will start floating. Now, what is the difference between the sinking and floating? Now, why do you float? Is it because of the gravity is high? Is it because of the gravity is less? Simple. Tell me. Gravity is less. Now, already we know what is the equation for the weight. What is the equation for the weight? Weight is equals to mass into gravitational force. No. So, mass into gravitational force is the weight. Now say the person on the moon, the person on the earth, what is his weight? What is his weight? Calculate. 60 multiplied by gravitational force on the earth is what? 10. So 60 into 10 is 600 Newton. You know what? More than the earth, the moon is less than 6 times less than the earth. The gravity is 6 times less, which means we take it as 1/6 of the earth. The gravitational force of the moon is 1/6 of the earth. So that means if they ask a question, find the weight of the man on the moon. Find the weight of the man on the moon. Yes, yeah. So what is our equation? You have to use the 1/6 and you have to use the weight on the earth. So 1/6 multiplied by weight of the person on the earth, substitute 100. So what is the weight of the person on the moon? 100 Newton. Did you understand? Did you understand? So when he go to the moon, he becomes 100 Newton due to the gravitational force of the moon. Did his mass change? Did his mass change? No. The mass is same. The gravity is change. Clear? Understood? Got the idea? Where did the 10 come from? This 10. Gravitational force on the earth is 10, no? The gravitational force on the earth is always 10. I already taught you. 1/6. 1/6 means the gravitational force of the moon. Gravitational force of the moon is 1/6. It comes as a fraction. If you don't take it as a fraction, it comes as a decimal, where you can't even do any calculations. It will be really complicated. That's what we have given it as fraction. Clear? Shall we go to the frictional force? So chapter 4 is also done. Any doubts? Hope there is nothing to be clear and you got an idea about this lesson clearly. Okay? Right. Always the question. Is it always 1/6? Yes. Always the question for this moon will be related. Question for this will be related to the moon. Sometimes they can ask about the moon, but I could remember most of your term paper only they ask about the moon. But really, I saw only one question in your O-level paper, but they do not ask much. But sometimes they can ask this year. So I just taught you everything. I'll try, okay, inshallah. Right, okay, let's talk about the frictional force. About the moon is very rare. Someone asked me to explain, that's what I told you. Should we calculate the Earth's weight and 1/6 of the mass? That means, first of all, you have to find the weight on the Earth. Whenever you want to calculate the weight of the moon, the first step is find the weight on the Earth. After you found the weight on the Earth, you have to substitute with the 1/6. So once you have substituted with the 1/6, you will get the weight on the moon. Weight on the moon. That's how. Clear? Okay, I'll give a small question to you. If I give a small question, see whether. No, we'll try to give a question to you in that way. Say, for example, 120 kg person is going to the moon. If the 120 kg person is going to the moon means, what is the weight of the person on the earth? What is the weight of the person on the earth? Weight. What is his weight on the earth? And what is the weight on the moon? Weight on the moon. Just give a try. Small calculation. Okay. What is the weight on the moon? Weight on the moon is weight is equals to mass into gravitational force, which means what's the answer? So here you will get it as 1200. No, you will get it as 1200 Newton. So when it comes to the moon, 1/6. So 1/6 into 12,200. So 12 is cut off. 200 Newton. Everyone understood how to do the calculation? Simple. That's it. Clear now? Clear, right? Okay, right. Yeah. On the earth, you are 1200 Newton. Newton is different. You will learn that later. Now, if I want to tell how 1200 came, how Newton came to the earth means, you have to learn a lot about it. No? Why is it 1/6? The reason because the gravitational force on the moon is less than the earth. 6 times less than the earth. So because of that only 1/6. Clear? It's given in your textbook. So we can't change. Right. Shall we start the frictional force? Turning effect of a force? Equilibrium of force? All of them after the break? Yes, 8:30 to 9 break. So from 8:30 to, yeah, it's a dinner break. You can have your dinner, go pray, come back. 8:30 to 9. So right, if you want to charge your phone, you can go and charge, and I will be ending the meeting, and I'll be starting the meeting by at 9. Okay, 9:10, if not by 9. So you can come back by 9:10 if possible. Yeah. So right, go refresh, come back, do all your prayers and do all your works and come back, because no more breaks will be given. Yeah, you can leave. Yeah, you can come back by 9:10 or by 9. Okay, bye.
Hi everyone. Am I audible? Try to share this link with your friends. Now, those who are not in the meeting. Right. So I hope you all have done all your works and then you are back here. Okay, we'll get started. Oh, is it? Right. Parallelly, you can have your dinner while you are in class. Okay. Right. So let's get started, and I hope everyone are here, and few of them has not written. Okay. Right. Anyways, let's get into the class. Yeah. I will be sharing the recording. But the thing, when I share the recording, I don't know whether you have time to watch them. Do you understand? Because not every time you will be free, you have to focus on other lessons also. So try to join the live class, then finish it off. You don't have any pending work. Right. Let's get started with frictional force. So let me start and I'll show you the video. So how many of you all are doing health here? Anyone doing health? Okay, so those who are doing health, we have a session on 14th, Friday. So try to join, like we'll be completing the both grade 10 and 11. All right. I know few of most of them does ICT. Those who are doing health, you all can have a look into that. Okay, right. Let's get into the lesson. I think it's after 6 only, 6:30 to 12. However, I'm doing Islam, health, and science. That's it. I don't get time to read the YouTube live messages because I am focused on the Zoom now. That's what. Right. Let's get started with the frictional force. Along with that, we have to move with the uh, turning effect of a force. It's about like full of logics and all. You have a lot to learn. So we'll study. Right. Yes. I already said no. Saturday and Sunday we have a free session for the Islam grade 10 and 11. It's also a recap session. So we'll be focusing on that. Right. Let's start with frictional force. So as usual, not hurry. We will be going patiently. Frictional force. Because in this part, you have to learn certain things. Okay, listen. Now, say for example, you have an object. Let's say for example, you have an object. Now, this object is moving in this particular direction. Now, say this object is touching the surface and it is moving in this particular direction. Now, there is something called relative motion. You have to learn the word called what? Relative motion. What do you mean by the word relative motion? Means the motion of the object that is relative to the surface and that is moving, we call it as relative motion. Say for example, this is you and you are touching the surface of the ground and you are casually walking to your classroom. So this is your relative motion. So what do you mean by relative motion? Means, what do you mean by relative motion? The motion of the object that is relative to the surface and moving, that we call it as what? Relative motion. Now say for example, say for example, you are casually walking towards this direction to your classroom.
Now you saw your enemy who is coming opposite to your direction, and he is not letting you to go to the classroom. So this is the classroom door. He is not letting you to go to the classroom. He's like, hey, stand here. Here, you can't go there. So what is he doing is, he is not that means he's not letting you to go to the classroom. Now what is your relative motion here? This is your relative motion. Now your enemy is what? Is he coming towards the relative motion, or is he coming opposite to the relative motion? So you can see that your enemy is coming opposite to the relative motion. That person, we call it as frictional force. That we call it as what? Frictional force. So what do you mean by frictional force? A force which oppose relative motion of the object when objects are in contact with each other. We call that as what? Frictional force. So you know what is frictional force? Listen to me. This is you. You are casually walking to your classroom. So you are without any problem, you are moving. So moving by touching the ground, we call that as relative motion. Now say you got an enemy, that enemy is coming opposite to the relative motion, not letting you to move to the classroom. So that person, we call it as frictional force. So what do you mean by frictional force? Frictional force is a force which oppose means what? Opposite, oppose relative motion of the object when two objects are in contact with each other. That we call it as what? We call that as frictional force. Did you understand? So say for example, if the object is moving in this particular direction, means, now say the object is moving towards the east, means what can be the direction of the frictional force? What can be the direction of the frictional force? Very good. It will come towards the west. So always frictional force is opposite to the relative motion. Clear with that? Understood that? Got the idea? Right. Now listen to me carefully. Now what you have to understand is, now say for example, in exam, they had given, I could remember maybe 2018 or maybe 2017, I saw a paper with a question like this. It was an MCQ. So they have given a picture like this and something like this in this way. Okay. And they have marked this as B and marked this as A, and then they mark this as D. The definition for the frictional force is a force which opposes a relative motion which is in contact with the surface. Okay? Right. So now say for example, this is C. So they had given a MCQ. I could remember. So they have given an object like this. This is B, A, D, C. They have given. And they said that this object is moving in this particular direction. So they have mentioned an arrow like this. The object is moving in this particular direction. Okay. Now remember, listen to me. A new word you will be learning today is, now say, if I am pushing this object, that means I am giving a force to this object. No, the object that I give to the force that I give to the object, we call that as applied force. We call that as what? Applied force. So what do you mean by applied force? Applied force means what? Say you have an object, I am giving a force to this object to move. So that means the force given to this object, we call that as applied force. Okay, right. Now say the applied force of this object is towards this direction. And they can ask you, in which direction the frictional force can appear? So what are the options they have given? Option A, option D, option B, option C. You all give me the answer. Very good, Rakib. Very good, Rahima. Very good, Azan, Mariam, Jazeel, Joanna and Preeta, correct? Others think and say me. Now say, the object is moving in this particular direction. Now they are asking in which direction the frictional force will be. In which direction? Very good. The B. The friction, if the object is moving, say you are moving in this direction, your enemy is coming opposite to you. So what will happen? If you are moving this side, the enemy will come the other side. If you are moving towards the A, what will be the direction of the frictional force? It will be towards the B. Did you understand? Did you understand? Clear with that? Right. Now listen. There are three types of frictional force. There are three types of frictional force. So when you talk about frictional force, there are three types of frictional force. So let me talk about the three types of frictional force. So there are three types of frictional force. Number one, we call it as static frictional force. Other one, we call it as limiting frictional force, right? And the third one, we call it as dynamic frictional force. So what are the three types of friction we have? Static, dynamic. Now, whenever we talk about static, what does the static stands for? We already know static means not moving. When we talk about dynamic is opposite to the static, which means we call it as moving. Now, whenever they say when an object is not moving, do they have a resultant force? Do they have a resultant force? Do they have a resultant force? No, they do not have a resultant force. Now, when they don't have a resultant force, do they have a relative motion? Do they have a relative motion? Can you move? No. So, no relative motion. So, there is no relative motion because it is a static frictional force. Think about dynamic. It is opposite, moving. Do they have a resultant force? Do they have a resultant force? Yes. Do they have a relative motion? Yes, they do have a relative motion. Right. Now, let me talk about static frictional force in detail. Remember, chapter 2 of your grade 10 will be connected to this. Okay. And chapter 4 of your grade 10 also will be connected to this connection. Okay, listen. Now, say for example, you have an object. Say, for example, you have an object. This object is in contact with the surface. Say, for example, you have an object and this object is in contact with the surface. And say, you have given an applied force of 10 Newton. Say, for example, you have given an applied force of 10 Newton. Now, say, in this surface, the maximum frictional force is 50 Newton. The maximum frictional force on the surface is 50 Newton. Listen to me. The force that you have applied is 10 Newton. The frictional force of this surface is 50 Newton. Listen to me. I'll explain what is this situation. Say, for example, this is you and this is your enemy. Your enemy is pushing you with 50 Newton. And you are pushing your enemy with 10 Newton. Who will win? You or enemy? Who will win? Enemy will win. That means if you want to beat him, if you want to move forward, should you give your applied force more than 50 Newton or less than 50 Newton? You should give your applied force more than 50 Newton or less than 50 Newton. More than 50 Newton. Okay, now listen. Think about this situation. Say, I am giving an applied force of 10 Newton and the frictional force on the surface is 50 Newton. So now what is happening is, you need to understand. Now say, you have a car. Now car is very heavy. Okay, so if one person pushes the car, will the car move? If one person, yes Azan, if one person pushes the car, will the car move? No. So even though you have applied a force, car will not move. Say 10 people pushing the car, will the car move? Yes. Now let's come to this situation. Now listen. Now remember, if your applied force is larger, always remember, whenever you should have a resultant force, what is the condition? Applied force should be greater than the frictional force. So then only you will have a resultant force. If you have a resultant force, what you will have? You will have a relative motion. So there will be a relative motion when you have the resultant force. Did you understand? Clear with that? Got the idea? Now let's talk about this situation. Now when we talk about this situation, listen to me carefully. Now what has happened is, now to move this object, I should apply a force more than 50 or less than 50. I should apply a force more than 50. Right. Now listen. Now in this situation, is the board is blurry? Is the board is blurry? Okay. No, it's not. It's in. Just check with your connection. Right. Now listen. Now, according to the Newton's third law, now say for example, this is a car. Has anyone experienced pushing a car? Only you. Have you tried to push the car by yourself? Just push and see. No. If you have pushed the car, say, if you push the car by yourself, the car will little go front and then it will come back to the place where it was. Did you notice that? Did you notice that? Now see, you have given a small force to the car. Car will slowly go front and then it will come back to the exact place it was. Now this is according which Newton's law? Every action is equal and opposite reaction. It went front, came back to the exact place. This is according to the Newton's third law. So according to the Newton's third law, when you push the car with 10 Newton, it is coming back with how many Newton? It is coming back with how many Newton? Very good. 10 Newton. It is coming back with what? 10 Newton. See, if you want to, listen. Some people are confusing. Listen. The frictional force of the surface is 50 Newton. Don't go with this 50 and 10. Don't go to do the resultant force with the 50 and 10. That's wrong. Listen, you have to beat more than 50 to move the car. Now what is happening is, when you push the car with 10 Newton, car will slowly go front and it will come back to the same exact position. Because of what? Did you push the car more than 50 Newton? You pushed the car with less than 50 Newton. So what did happen? Car went front and it came back to the exact position according to the Newton's third law. So now what happened? If the car is given as 10, it came back to the exact position with 10. What will be the resultant force of this car? What will be the resultant force of this car? This car will have the resultant force of 0. Did you understand? Did you understand? So always remember, the object will always move in the direction of larger force. Now say, now some people who didn't understand, listen. Now, if I apply a force of 10 Newton, this direction means my enemy is giving a force of this direction 50 Newton. Now who will win? Will my enemy win or will I win? Your enemy will win. Why? He is giving a larger force than you. That's what, when you give 10 Newton, you are coming back to the exact place where he pushed you. Did you understand? Did you understand? So according to this, the resultant force is becoming 0 because of what? If the object is moving. If the resultant force is there, if there is no resultant force, is the object is moving? No. So which means, what kind of a frictional force is this? What kind of a frictional force is this? This is, we call it as static frictional force. So static frictional force, where the object will not move. Clear with that? Understood that? Got the idea? So this is, we call it as static frictional force. Right? Clear? Okay, now listen. Now what is happening is, now you have increased. Now say for example, you called 5 of your friends. Imagine. Now say for example, the same example I am using here. So this object is in contact. The frictional force is 50 Newton here. And then you called 5 of your friends to push the car. 5 of your friends is pushing the car. So each person is giving 10 Newton, 10 Newton, 10 Newton. And then you called one of your cat also to push. The cat gave you 0.1 Newton. Imagine. What is the situation when there is no? Wait. When there is no frictional force. I'll tell you what is that. Right. Now listen. Now what is happening is, now when you have 5 people and you have called one of your cat also to push. Now what is happening? Totally how many Newton are you having at the as the applied force? As an applied force, you have 50.01 Newton. So you have what? 50.01 Newton as the value. So now what has happened? So 50.01 Newton, you have received it. Now what are you going to do right now? What are you going to do? You can even take it as 50.1 Newton also you can take. Now what is happening here is, now is the applied force is larger than the frictional force? Yes or no? Is the applied force is larger than the frictional force? Yes. Okay. Now, will the object move? My question is, will the object move? It's like this, no? Like a point wise, no? Because it is in point wise, will the object move? No, it's about to move. If someone come and give a solid push, the object will move. It is in the state in that way. We call that state as in the wage of motion. In the wage of motion. So, in the wage of motion means it is larger than the frictional force a bit, but it can't move, but it is about to move. If someone gives 1 more Newton, it will move. In that way, it is about to move. It is beginning to move. It is starting to move. So that you call it as limiting frictional force. Okay, it's word, okay? Limiting frictional force. So what do you mean by frictional force? Limiting frictional force. The frictional force acting on an object when the object is on the verge of motion, that you call it as limiting frictional force. Clear with that? Understood that? Got the idea? Right. Okay. Another name for the limiting frictional force, they call it as maximum frictional force. So another name for limiting frictional force, you call it as maximum frictional force. So I'll tell you what is limiting frictional force again. Initially, what was the situation? You was pushing the car with 10 Newton and the frictional force on the surface is 50 Newton. Frictional force on the surface is 50 Newton. Now what is happening? You called 5 of your friends. So equally, they are giving 10 Newton, totally 50 Newton. So now what happened? You called your cat also to give a push. So it gave you around 0.1 Newton force. Now what is happening totally? Totally 50.1 Newton comes as a applied force. So now when you compare to the frictional force, your enemy's force, are you more than him? Are you more than him? Yes, you are more than the frictional force. But can this object move? Now see, it's a point wise. It is point wise. It's not solid. It's not 51 Newton. It's 50.01 Newton. That means it's point wise little up, a bit more. But can this object move? No. That means the object is about to move. We call it as in the verge of motion or in the verge of motion. Right? So this we call it as limiting frictional force. So what do you mean by limiting frictional force? Frictional force acting on an object when the object is on the verge of motion. When the object is on the verge of motion. That we call it as limiting frictional force. So limit frictional force can be called as maximum frictional force. Do you know why? Initially you had 10. Now how many more increased? How many more increased? Initially you had 10. How many more increased? How many more increased? Forget about the 10 you gave initially. How many more increased? Very good, Shahda. 40.1 Newton. That means who is having the highest force? Limiting frictional force. So that's the reason we call the limiting frictional force as the maximum frictional force. Clear with that? Clear with that? Got the idea? Right. Now let's go to the next one. Now say for example, now instead of your cat or something, a person another person. He came, he just pushed your car with one hand by giving 1 Newton. By giving 1 Newton. Now what has happened? Now what has happened? Will the object move? Now it's solid 51 Newton. Will the object move? The object is more than the frictional force. So will the object move? Yes. The object will be moving. So what kind of a frictional force is this? You have a relative motion. You have a frictional force. This you call it as dynamic frictional force. So in this dynamic frictional force, what do you need to understand? Is dynamic frictional force is higher than the limiting force? Limiting frictional force? Is the dynamic frictional force is higher than the limiting frictional force? Just think and say me. Okay, now those who are saying yes, listen. Initially, you gave 10. That means static frictional force is how much? Static frictional force is 10 Newton. Then you called more people. That is 40.1 Newton increase to make it 50.1 Newton. Isn't it? So this is limiting frictional force value. Now one person came. That means 1 Newton. You got increase. That means dynamic frictional force owns only 1 Newton. Now tell me who is highest frictional force here. That means who is the highest maximum friction here. Is that the static? Is that the limiting or is that the dynamic? So remember, limiting frictional force is the highest frictional force. Clear with that? Clear with that? So limiting frictional force has the highest frictional force. Not the dynamic, not the static. Clear? Right. Now we need to study about few questions like this comes in your 2017 O-level paper. How to find limiting frictional force in the sense? Usually limiting frictional force will be more higher. That means it is on the verge of motion. Okay, some people asking me to explain again. Listen to me. Static frictional force means, remember, it will be less than the frictional force of the surface. Static frictional force, the applied force will be less than the. How did you get 40.1? Now say you called 4 of your friends along with the cat. With you, 5 people are there. With you, 5 people are there. So each people giving equal amount of what? Equal amount of forces. 10 Newton, 10 Newton, 10 Newton. But remember, initially you gave 10 Newton. So can I count the 10 Newton for the limiting? Can I count the previous 10 Newton? I can't count. It was already there. So what is the rest? 4 people came along with the cat. That's what? 40.1 Newton. Did you understand, Rahima? So that is the limiting frictional force given. And then after that, one person gave 1 Newton. He gave 1 Newton. And then the object started moving easily. So that means, why can't count? Why can't count in the sense, this person is there. No, already you gave this. No. So this belongs to static. Something that is belong earlier. Something that is given earlier belongs to static. Along with the static, you started to increase the applied force. So can I take my value? No, already I have given. That is considered as static. That's the reason I told you. I can't take my value. However, you can't take, no, if you give something earlier, can I again count that as the same thing? I can't do it, right? So that's the reason I don't count my value. I will, how many more increase? How many more? After 10, how many more increase should be the question? How many more increase? 40.1 Newton has been increased. So that is what I told you, right? In 2017 paper, in O-level 2017 paper, there is a question, okay? There is a question and they have given a graph and that is very important, okay? So that graph, we call it as frictional force versus applied force. Frictional force versus applied force. So both of them are measured in Newton, right? Now listen to me. The maximum frictional force on the earth is 40 Newton. Say for example, the maximum frictional force on the earth is 40 Newton. Okay. Okay, now listen. Now what is happening is,
limiting friction force. Limiting friction force is greater because limiting friction force is 40.1 Newton. No? But when it comes to the dynamic has been increased from where? Initially it was 50.1 Newton and one more Newton has been increased. So that's the reason it became 51.1 Newton. It became 51.1 Newton because 1 Newton has been increased. So the 1 Newton has been increased to detect the dynamic friction. So dynamic friction is helping only 1 Newton help to move. So that 1 Newton is belong to dynamic. The rest of the value is belong to the limiting. So that's the reason limiting is highest. The middle person is highest. Okay, right. Now listen. Now what is happening is the maximum frictional force on the surface is 40 Newton. Now say for example, if I give an applied force of 10 Newton, I will be coming back with how many Newton? First situation, if I applied a force of 10 Newton, what will be my frictional force? Every action has equal and opposite reaction. Tell me. I will come back with what Newton? The friction will be 10 Newton. If I give a force of 20 Newton, what will be my frictional force? Always remember, if my applied force is more than frictional force only, I will not reflect. All this time I will start reflecting. It will be 20 Newton. If my frictional force is 30 Newton, what will be my, again, that is also 30 Newton. If it is again 40 Newton, again you will have the 40 Newton. Now say for example, instead of giving 40, I have given 40.1 Newton. If I have given, let me draw the graph properly. It's not visible. Sorry. Okay. So now what happens? So what happens? The object is until here. From 0 to 40, is the object is moving? From 0 to 40, is the object is moving? Think. This is the frictional force. This is the applied force. 0 to 40. Frictional force is 40. Applied force is 40. Think well and say. No, object is not moving. That means what kind of frictional force are you looking for here? What kind of a frictional force is that? That we call it as static frictional force. Say for example, you have applied a force of 40.1 Newton. Now what will happen? This point will raise up a bit. This point will raise up a bit. The reason why did you call it as static? Listen, this is a frictional force on the earth. This is the frictional force on the earth. This is your applied force. If you give a force less than 40, will the object move? If you give less than 40, will the object move? Until you come to the 40, will the object move? No. Still the friction. Always remember, if the object has to move, the applied force has to be more than the frictional force. The applied force has to be what? More than the frictional force. Now what has happened? Now what has happened? Say you are giving a force of, let's say for example, you are giving a force of 40.1 Newton. If you are giving a force of 40.1 Newton, what will happen? What will happen to the graph? The graph will slowly move up and then it will come down. It will go up and it will come down. Now what is happening? Now say for example, you are giving a force of now 41 Newton. So when you give a force of 41 Newton, it will go a bit up and it will move straight. So the point at the peak, we call these as limiting frictional force. The point that comes down,
we call it as dynamic frictional force. So you ask me, why was the dynamic is down? The reason because dynamic is less than limiting frictional force or more than limiting frictional force. I already proved you in the theory. What did we understand? Let's know. So that's the reason dynamic is coming down and going straight. Clear with that? So who is the maximum frictional force over here? The limiting frictional force is the maximum frictional force. So in exam, they can give you a chart like this and they can ask you to mark the graph in this way, and they can ask you, why is it up, why is it down, and why didn't this 20 and there is 20 on the other side. So you have to explain. Clear with that? Got the idea? If we apply 45, then the frictional force will be 5 Newton. I didn't understand. You mean, yes, you are asking that the dynamic friction. If you apply 45, the dynamic will be 5. No. Limiting at one point, it will go up and then it will drop and come down to show it is dynamic. Clear with that? Drop and come down. That's the nature of the graph. Since the maximum frictional force is a limiting frictional force, it will show I am limiting and then it will come down to show the dynamic. Now it started to move, no? Before started to move, moving with the uniform velocity. Clear with that? In exam, they will ask you to mark the graph. And they will tell you to do that. Okay, can someone, okay, right. Shall I give you a question related to this? I'll give you some data. Try to draw the graph and tell me whether you get it correct. Okay, try to draw the graph and give an idea. Okay, right, I'll give a try. Say for example, you have to draw a frictional force versus applied graph. Okay, so the maximum frictional force on earth is 60 Newton. That's the maximum frictional force. Okay, now for example, you are giving a force of 20 Newton, you are giving a force of 40 Newton, you are giving a force of 60 Newton, and then you are giving a force of 80 Newton, and then you are giving a force of 100 Newton. Think well where the peak has to rise and go down. Okay? Quickly. Simple. Simple, nothing to get scared of that. You can do it. If we are done with this lesson, we can go with the turning effect of a force. So there you have lots of questions to do with me. So yes, Hannah. Very good, Jana. Others? Okay, very good. Okay, I could see good positive answers from you all. So what will be our graph? So our graph will be here, you will have 60, say for example. So until here, you will have 20, then 40, and then you have 60. Then from 60 only, everything will be started moving, no? Everything will be started moving from 60. So from 60, there will be a small up. Then 80, 100 will be a direct. Because from 60, no, after the 60 only you don't have any frictional force. So the maximum frictional force on the surface is 60. So when it goes more than 60, you have to raise up and go straight. That's it. Nothing else.
Okay. Any doubt? Yes. By 12, Zainab. Okay, right. Now let's move on. Let's talk about factors affecting frictional force. So let's talk about the factors affecting frictional force. So when we talk about the factors affecting frictional force, always remember, if one of the factor changes the frictional force, everything will be changed. So remember, I will give you an equation. This equation is there in your A level. It's there in your A level. But I'm saying you may ask me, since it is in A level, if I write this, will it get wrong? You may ask. Okay. You will be getting this kind of graphs. Okay. Yes, Shakib. Okay. So now when you talk about frictional force is depending on two factors. Number one, coefficient. We pronounce this as nu into r. So what is the equation that you have to remember? By the equation of frictional force, we remember the factors affecting the frictional force. Number one, nu. How do we spell nu? We say nu, no? So this is how we spell nu. Then r, we call this as normal reaction. We call this as what? Normal reaction. Now if you ask me what is nu, nu means coefficient of friction. Coefficient means what? What do you mean by coefficient? What are the coefficient things that is affecting the frictional force? Number one, smooth surface. Number two, rough surface. So rough and the smooth surface can affect the frictional force. Normal reaction also can affect the frictional force. So these are the two factors frictional force is depending on. So better to know the equation so you don't want to by heart the factors that is related. Now instead of coefficient, we can call it as what? We can call it as nature of surface. We can call it as what? Nature of surface. Instead of that, we can call it as nature of surface. Listen, there are two factors that frictional force is depending on. Number one, normal reaction. Number two, nature of surface. So what are the nature of surface? Smooth surface and rough surface. And normal reaction. I'll explain you what are those. I'll explain. Listen to me. Now, when you talk about, now if any of these factor increases, say the normal reaction increases, frictional force will increase. If the, let's say, if the nature of surface increases, then the frictional force will increase. Let me say you how this is affecting. Let me talk about how this is affecting. Let me start with normal reaction. Let me start with normal reaction. I could remember someone told about perpendicular reaction. No? So the normal reaction also we can call it as perpendicular reaction. Now listen to me. Listen. Now this is something that is out of the box, but I'll explain you by taking a bit of time because no one knows about it. Right. Now let's talk about normal reaction. So when you talk about normal reaction, say you have an object which is 5 kilogram. Say you have an object which is 5 kilogram. Now guys, tell me what is the weight of this object? What is the weight of this object? Yes, what can be the weight of this object? But how did we learn? Very good. This is 50 Newton. In which direction will the weight act? Now say you have an object. The object will be acting towards the center of the earth. That means towards which direction that the weight will be reacting? Downward, no? Always from the center of the object towards the south. Always the weight will be reacting. So the direction of the weight will be acting towards the center of the earth, which is downwards. Okay. Now what is Newton's third law? Every action has equal and opposite reaction. Now imagine the box is on the table. Imagine the box is on the table. Say I have taken a table over here and then I kept the same box on the table. Okay. Now imagine what is the force that is acting on the box? From the center of the box towards the table, the force that is acting is weight. Always remember. Now, if the object is hanging,
imagine if the object is hanging. What is the force that is opposite to the weight if the object is hanging? You told me recently when you are studying about Newton's law. When the object is hanging, what do you call that as? What is that force name that is opposite to the weight? Ah, very good. You told that as tension, no? I told you that tension will appear. When will the tension appear? Listen, always remember, tension will appear whenever object is hanging. Whenever object is hanging. That's what the bulb that is hanging in your home, is it moving? No. But think, I kept this duster on the table. Why the duster is not moving? Now duster is not hanging as well as it is not moving. What can be the reason? Now think, the box is not hanging. It is on the table. Do you have tension? Do you have tension? Do you have tension? No. But the object is still. Now I told you, if you have an object at rest, if you have an object at rest, say object is giving a force in this direction, means there should be a force in opposite direction to be rest. No. Same like that, this object is kept on the box and the object is giving this force in this particular direction, means the table also will give a opposite force, opposite reaction force. We call that as normal reaction. If the box is giving 50 Newton, the table also will give the force against the weight, that is 50 Newton. That's the reason whatever the things you kept on the table doesn't move. Clear? Understood? So this normal reaction, I can even call it as perpendicular reaction. I can call it as what? Perpendicular reaction. Clear with that? Clear with that? Got the idea? No, Umukulzum. Clear with that? Right. Now what is the thing? All this time we were talking about the weight, no? Weight is depending on what? The force that is against the weight, we call it as normal reaction. Now what are the two factors that the weight is depending on? One is mass, other one is gravitational force. Zora, you have told perpendicular reaction is called tension when it's hanging. Yes, Zora, that's correct. When it is not hanging, we call it as normal reaction. When it is hanging, we say it as tension. Clear now? Yes, Hana. Right. Now listen. Now what has happened? We understood weight is depending on mass and gravitational force. My question is, will the gravitational force change? Will the gravitational force change? Will it change? No, right? Now if I say, if the object is 10 kilogram, means, will the weight increase? Yes, no. The weight will increase, no. If it is 10 kilogram, the weight will be 100 Newton. Isn't it? Now, if the weight is 100 Newton, we know that normal reaction is depending on the weight. Remember, normal reaction, let me mark it as R itself. The symbol for the normal reaction is R. Normal reaction is depending on what? Weight. Weight is depending on what? Weight is depending on the mass. Normal reaction, that means the frictional force, is depending on normal reaction. If the mass increases, the weight will increase. If the weight increases, normal reaction will increase. If the normal reaction increases, the frictional force also will be increasing. Clear with that? Did you understand the connection? Did you understand the connection? The main seed will be formed from the weight. So we know weight and mass are like each other. Yeah, we'll be covering. I told you we will have another session also. So I can't hurry. If I hurry, then I have to read. I don't like to read science. I will give you a maximum, okay? Whatever it is, I'll try to give. I'll manage, okay? Right. So now what is happening is, so weight will be equals to mass. Weight will be equals to mass. That means if the mass increases, weight increases. If the weight increases, normal reaction increases. If the normal reaction increases, frictional force increases. So can you please write this down and keep it with you? Got the idea? How are they affecting? Okay, shall I check your brain now? Shall I check your brain right now? Okay, now I'm going to check. Let's see whether you are alert. Let's see whether you got an idea. Okay. Quickly say me. Now, now say, for example, you have an object. Okay, you have two situations. Okay, you have two situations. One object is, let's say, you have one situation. Okay, your brain is braining, right? Great. Okay, now listen. Now say, for example, you have 12 amna. So now when you talk about 50 kilogram, now say you have an object with 50 kilogram and you have an object with 100 kilogram. Simply tell me, guys, in which object the frictional force is high? One or two? Very good. Two. Why? If the mass increases, the weight will increase. If the weight increases, normal reaction will increase. If the normal reaction increases, we know normal reaction is a factor that will affect the frictional force. No, frictional force will increase. Did you understand? Clear? No? You will get questions like this only. So no need to worry. Clear then? Okay, right. Now let's talk about nature of surface. Let's talk about nature of surface. So when we are talking about nature of surface, what are the two nature of surface I told you? Smooth surface and rough surface. Now just tell me, in which surface it is easy to move? In which surface it is easy to move? Smooth or rough? Smooth. So that means if you can easy to move means, does the smooth surface has friction? Does the smooth surface has friction if you can easily move? No. Right. Again, a small question to you. Now say for example, you have an object which is 80 Newton and you have an object which is 50 Newton. The object which is 80 Newton is on the smooth surface. It is on the smooth surface. Okay. The object with 50 Newton is in the rough surface. Now tell me, which object can move faster? Which object can move faster? Very good. Very good. Smooth surface can move faster. The reason why the smooth surface can move faster is because I didn't tell you force is affecting the frictional force. No, it can be any force. No worries. Smooth surface is very important. If you have smooth surface, there is no frictional force. If you have a rough surface, there will be a frictional force. Clear with that? Understood that? Got the idea? Right. Okay. Sometimes you need to increase friction. Sometimes you need to reduce friction. Now let's say you are playing carom. In this situation, do you need to increase friction or do you need to reduce friction? Should the board has to be smooth or should it be rough to play? It should be smooth, right? So to reduce the friction on the board, what you will do? You will be adding what powder? What powder you will add? You can say talcum powder or boric powder. So how can you reduce friction? How can you reduce the friction? Friction can be reduced by the boric powder, by applying boric powder on the carom board. Second, now I'm talking about how to reduce friction. Now, say you have a lock and a key and they are not opening properly. You have a rusted gate. They are not opening properly. If I want to make that smooth opening, what should I do? What should I do? I have to apply lubricant oil or grease to reduce the friction. Clear with that? Now think about the machines. Think about the machines that is working in the factory. How does it work smoothly? Because they have some ball bearings to control the work. Now look at the mouse that we have. The mouse will be quickly, computer mouse, it will quickly rotating. No, why? You have a ball bearing. So when there is a ball bearing, you can easily move your mouse, right? Now tell me, how can I increase friction? There are some importance that can increase the friction. Usually, footballers, have you seen their shoes? They have some grooves on their shoes. Have you seen some grooves on their shoes? What is the reason they have grooves on their shoes? What is the reason? Now, if the shoe is slippery, now say if there is no grooves on the shoe, and if you are wearing a plain shoe, can they run faster? No, they can't run faster. To increase the friction, you need more grip. That's the reason they can run faster without slipping. So that's the reason we need friction. To walk, we need friction. To run, to swim. Okay, I'll ask a small question. Now, when you go to washroom, we all of us wear slippers. No, we used to wear slippers. No, have you noticed the slipper of your washroom? And have you ever felt to slip in the washroom by wearing a slipper? Any situation? Yes. Why? Why? Did you look at the slipper back? What has happened to the grip? There is no grip. Grip is faded. All slippers only put into the washroom. Finally, you will break your head and come. So you are supposed to wear a new slippers. Why? There should be a grip. Mostly in washrooms. One of my grandfather. Okay, it's now a bit far relative. He passed away. How you know? He went to the washroom. He slipped and he fell and knocked his head and he passed away. He's not that much age. But the problem was the slipper. The slipper has less grip. It was very plain. So he slipped and he fell, and the door got locked or something happened. So you need to be very careful. You have to have friction in your leg. That's the reason. Sometimes when your mama mop the house, marble tile, what happens? Suddenly you will start slipping. Why? Your leg will be losing friction. So friction is very, very, very important. Clear with that? Sports car. Did you see how big is the sports car? Do they have grooves? H grooves? Yes. Then only they can ride on the desert, ride on the slippery roads and all of them during the rain time to avoid skidding. That's the main reason to have friction. Clear with that? So frictional force is over. Lesson frictional force is over. Clear? Got the idea? Right. Shall we go to the lesson turning effect of a force? That's also easiest lesson. You will feel easy when you do it with me. Okay, right. Let's get ready. And this is going to be interesting lesson. And you should have a paper and some pencils, some pencil with you. Yes, sometimes when I talk, I will miss my grammar and all. Don't worry. Continuously talk, I will have tongue skidding. We will do questions, no worries. Because we have to learn. No? If we do questions, the time will be gone. So I will take another day to discuss the questions and all of them. So you will get to know. Right. Let's say turning effect force. Okay. When there is an unbalanced force, there is always a friction. So smooth surface also have a friction. They have a little bit of friction, not too much. They will have a bit of friction, not too much. Turning effect of a force. How many of you felt hard this lesson? Don't understand something turning and waiting. Don't know what is that. Something is a balance rod is given, and they are asking me to they're asking me to balance it out and give it to me. But I don't understand. So some people have an idea regarding that. No. Okay. So today I'm going to give you a very good tip. Listen to me. Okay. Now in this lesson, I will start up with, now say for example, whatever we studied, okay? So whatever we studied, it's okay. Right. So, right. Some school, they don't have teachers. I do understand. We'll see. Okay. Now say for example, you have an object. Okay. You have an object. You need to push the object. What you have to do? Now say, I want to push this object. What you have to do? You have to apply what? You have to apply force. Now, is the statement that I told is correct? Is the statement that I told is correct? Can someone correct me soon? What kind of force should I need to move? What kind of force should I need to move? Is it just a force? Very good, Rahima. What kind of force? Applied force or resultant force or force? Think nicely. Applied is this force also applied only. This force also I call it as applied. Now tell me, what force should I need? What force? Very good. I need resultant force. So if an object has to be moved, I need what kind of force? I need a resultant force. Clear with that? So by applying a resultant force, you can only move the object in one direction. Now see, if I need to rotate the object, if I apply a resultant force, is that enough? Is that enough? Now say this is not marker. I'm saying say you have a big object and you wanted to rotate. When you wanted to rotate, do you need a resultant force or do you need a force that is something different? You need a different force that we use for rotating. We call it as what? Moment of a force. So what do you mean by moment of a force? The force that we use to rotate, that we call it as moment of force. What is resultant force? Resultant force will be helping your object to move in one direction only. It will move in one direction. But moment of force what? 360 degree. 360 degree. Did you understand? Did you understand? Now listen to the condition. If applying a moment of force, the object should be fixed at a point. Remember, if you are going to do a moment of force, say you are going to rotate something, that object should be fixed at a point. What did I say? If you wanted to rotate an object, that object should be what? It should be fixed at a point. Now say for example, you have an object here and then you are going to rotate this object. The object that you are going to rotate should be fixed at a point. The point where the object is fixed, we call it as axis of rotation. We call that as what? Axis of rotation. So what do you mean by axis of rotation? Axis of rotation means what? The point where the object is fixed. Say you have this one. Let's say for example, this is an object. If this object has to be moved, it should be rotated. It should be fixed at a point. That point, we call it as what? Axis of rotation. Clear with that? Got the idea? Now say me, if I need to move this object, now say for example, if I need to move this object, if I apply a force in this direction, say if I apply a force in this direction, can I move this object? Say, think, I have drew like this. Think the same thing. It is fixed. And if I give a force, will this object move? Will this object move? Yes, the object will move. Now think, this is fixed. And if I give a force at this particular direction, will this object move? Will this object move? No, the object will not move. So if I apply a force in this direction, can I rotate this object? I cannot rotate this object. Now remember, to rotate the object, you should apply a force. See, I am applying a force that is perpendicular to the direction of the force. That is perpendicular to the direction of the force. So now what did you understand? If you wanted to rotate an object, you should apply a force perpendicular distance to the axis of rotation. See, distance from the axis of rotation, then only you can rotate. Clear with that? Clear with that? So the equation comes for the moment of force. So what is the equation that comes for the moment of force? Moment of force is equals to force into perpendicular distance to the axis of rotation. Perpendicular distance to the axis of rotation. That is going to be the equation. That means you measure the force by what? Newton. You measure the distance by meter. So what is the unit you measure moment? Newton meter. Newton meter. So remember, if you need to rotate an object, you need to have a force and perpendicular distance to the axis of rotation. Until here, did you understand? Until here, did you understand? Clear with that? Yes or no? Right. Now listen. Now, moment of force unit Newton meter. Now, say for example, you have a door. Say for example, you have the door over here. And you know, door is fixed at a point, no? Door is fixed at a point. What do we call this fixed at a point? We call this as what? Axis of rotation. We call this as what? Axis of rotation. Now, say for example, if I apply a force this side, now say this is the door. Okay, if I apply a force of this side, can I open the door? Will the door get open? No. But if I give a force like this in this particular direction, will the door will get open in this particular direction? Like this, think. You're standing like this. You're standing like this. If you give the force like this, will the door get open? No, right? But if you give a force like this, will the door open? Will the door open? Yes, no? That means, what did you understand? You have to give a force perpendicular to the distance, perpendicular to the distance of axis of rotation. So you have to give perpendicular to the axis of rotation. So here is the point. Here is the force. Perpendicular means what? It gives the 90 degree. It gives the 90 degree. Look here. If I give a force like this, it comes as a 90 degree. So you can open the door when it is. You can rotate an object when it is perpendicular distance to the axis of rotation. Clear with that? Clear with that? Got the idea? Okay, now look here. Now say, I am going to open the door by pushing at the point A and B. Okay, now say I am going to push at the B. I am going to push at the A. Now say me, which part will be difficult to open the door? Opening from the A will be difficult or opening from the B will be difficult? Usually think, where is our the handle is there? Usually handle is present here, no? Then why don't we here? Because opening the door here will be difficult. Have you ever tried? Anyone try to open like that? I mean, keeping your hand or like did some other works, try to open, but you felt very hard. Like, why the door is not coming? You may have thought from the edge also you may try to close. From the edge also you try to close the door, but you can't. You feel very heavy to close. But when you close from this side or open from this side, it's a bit smooth. So did you even feel like that? The reason because when you decrease the perpendicular distance, the moment of force will be constant. Now say for example, remember the moment of force is down. The moment of force is always constant. Remember, it is constant. The moment of force will be constant. Okay. Now, when you talk about it, shall we do a question and see why is it very difficult for us to open at the B? Now, look at the question here. Say, for example, you have a door. Okay. Yes, sometimes the finger also will be stuck. You have to be very careful. Now, say this is the door. Now, say, for example, from axis of rotation to the B is 5 meter. From axis of rotation to the A, let's say that is totally 10 meter. Okay. Now, let's say the moment of force they have given is 100 Newton meter, which is constant. For both the situation, it is constant. Okay. Can you find the force that should be applied at A? And can you find the force that should be applied at B? What is our equation for the moment of force? Force into perpendicular distance to the axis of rotation. Can you all find? Force 1, force 2. Can you all find it? Can you all find the force that we give at A? Can you find the force that we give at B? Very good, Rahima. Very good. Nicely think and do, Jonna. You can do it. Very good, Rukeya. Very good, Tharujay. Others? Now Joanna did correctly. Others think no? Say, look here. Moment of force is constant in the both the side, darling. It is constant. Same. What is our equation? Moment of force is equals to force into distance. Force into distance. So what is the distance from the axis of rotation to the A? 10. We don't know the force. What is the moment of force? 100, no, darling. Take the division 10 to the other side. 100 divided by 10, the force will be equals to 10 Newton, no? Isn't it? Do for the second one. How you can do it? 100 equals to F into 5. Take the 5 to the other side. 100 divided by 5 will be equals to 20 Newton. So then we prove that when you open from the B, nicely think and do. When you open from the A, you have to provide a less force. When you open from the B, you have to give a high force. That means I proved it. When the perpendicular distance is reducing, the amount of force that you have to supply is very high. Clear with that? Clear with that? Understood that? Got the idea? Got the idea? Yes or no? Yes or no? So if the perpendicular distance is increasing, the force that you have to supply is very less. When the perpendicular distance is decreasing, the force that you have to supply will be very high. The equation doesn't prove it. Yeah, that's true. But we have to get into that. Moment of force is always constant. They do not depend. Moment of force doesn't depend on these two people. Now, all this time, what we learned was depending. No, but this time, what we are learning here is doesn't depend on these factors. That means these two factors are quite opposite to each other. That's the truth. Even though we have the equation like this, the truth is when you open from this side, you have to give a less force. But when you open from the B, you have to give a higher force. Did you understand? Clear with that? Got the idea? Right. So now what you have to understand over here, what you need to understand. Now from this you got an idea how to do the questions related to the moment of force. Now let me give you more questions so you will get an idea. Right. Now say for example, now you have something like this. You have something like this. Now say, now what happened is, now let's say for example, you have a rod. You have a 1 meter rod. You have a 1 meter rod. Okay. Now, if I lose this 1 meter rod, will I be able to rotate it faster or harder? Will I be able to rotate faster? Or let's say, will it be easy to rotate or will it be hard to rotate? If it is loose, if the nut is loose that I have fixed, it is easy. If I have tightened it, what can you say about the rotation? Will it be hard or will it be easy? It will be hard. So the ability of rotation becomes hard. Therefore, what will happen to the moment of force? Moment of force also will be increased. Right. Now listen to me very, very carefully. Now, this is a rod. I am applying a force. So in this particular direction. Now say for example, I am applying a force to this rod in this particular direction. Now tell me, in which direction will the rod will move? In which direction will the rod will move? Will it move towards 1 or will it move towards 2? 1 or 2. That means if I take the clock, say if the clock is moving in this particular direction, we call these as what? We call these as anti-clockwise. If the clock is moving in this particular direction, we call these as clockwise. Is it moving in the anti-clockwise or is it moving in the clockwise direction? But do you understand? If I give a force at this particular situation, what kind of direction do you face? That means, am I going anti-clockwise or am I going with the clockwise direction? Clockwise or anti-clockwise? I have to put the direction other way. Sorry, I have to put the direction other way. So what is the answer? Your answer is anti-clockwise. Many of you all told correct. Now, in this lesson, can you remember resultant force? Can you remember you studied something resultant force? If you have the forces in the same direction, should you add or subtract? Should you add or subtract? You have to add. When you have the forces in opposite direction, should you add or subtract? You have to subtract, right? So the moment of force has a direction. It has a magnitude. Scalar quantity or vector quantity? Moment of force is a scalar quantity or a vector quantity? Very good. It's a vector quantity because it has a direction. Clockwise and anti-clockwise is a direction. Right. Okay. Now we are going to go with the question. Some questions that is really needed for you. Now say for example, you have a 1 meter rod. You have a 1 meter rod. And you are going to apply a force from the middle. You are going to apply a force from the middle and this is going to be your axis of rotation. This is going to be the axis of rotation. So this is going to be your axis of rotation and this is the force that you are going to give. So let's say you are going to give a force of 300 Newton to the 1 meter rod. Now if I divide the 1 meter rod, what will be the value of this both the side? What will be the value of the both the sides? Sometimes they do not give you the value, you have to find it. It will be 0.5 meter and here also it will be 0.5 meter, right? Now, what you have to do is, now if I ask you to find the moment of force, will you be able to find the moment of force? Will you be able to find the moment of force? Yes. Can you find the moment of force of this particular rod? Can you find the moment of force of this particular rod? Yes. And the object is moving clockwise or anti-clockwise? Is the object is moving clockwise or anti-clockwise? It is moving anti-clockwise. It is moving anti-clockwise. Right. Now tell me what will be the moment of force? Okay. Some people send me correct answer. Some people did some calculation mistake. Listen to me. What's our equation? Force is 300. Perpendicular distance is 0.5 meter. No? It's in meter. No? So what I can do is, I can jump the decimal 2 times. So I'm going to jump the decimal 2 times. So therefore, it will be easy for me to do the calculation. So what I will do is 300 multiplied by 1 time, 2 time, I will be jumping decimals to take it as 50 for easy calculation. You are taking it as 0.5, no dear? 0.5. So what I will do is I will turn that into a fraction over 100. So what I can do? cut the 0, 3 into 50 is 150 Newton meter should be your answer. Clear? Got it? When using the equation, should the distance be measured from the axis to the post or full length? You have to always measure from force to the axis of rotation. From the force to the axis of rotation. How did I get 50 in the sense? What did I do is, yes, listen. Now you had 0.5 meter, no? So since you had 0.5 meter, I have to do the substitution. So I have to convert this. So now what did I do? I jumped 2 decimal in order to make my equation, in order to make my simplification easy. So what did I do? I jumped 1 time and 2 times. So what happened? I took that as 50 and then over 100. The amount I jumped should be 100 over there. So then what happened? I cut off the zeros. 3 into 50, 150 Newton meter. You will find such question. I'll explain you further. Okay. You will feel a bit difficult here. I'll explain you further. Listen. Now what is happening is, now say for example, if I give a force over here, now I already found the moment of force. Is 150 Newton meter means, can you find the force that I should supply over here? Can you find the force over here? Now I told you this is 1 meter rod. If this is 1 meter rod, can you tell me the force that I have applied over here? Simply, what is the force that I have applied over here? What will be the force of here? What will be the force? No, I'm asking what is the force that I have applied to this edge. Now, since we know from the axis of rotation to here is 1 meter, that means already the distance, I know the distance, that is 1 meter. Moment of force is already constant. I already found wherever you keep the force, moment of force will be always constant. That means 150 equals to force. 150 equals to force multiplied by 1. Take the multiplication 1 as a division. 150 divided by 1. Answer is 150 Newton will be the force. So you can see here it was 300 Newton. When you come back to the other half back, you can see it's 150 Newton. So you need to understand, when you increase the distance, the amount of force that you have to supply will be very less. When you decrease the distance, the amount of force that you have to supply will be very high. Did you understand the difference? Yes or no? Moment of force can be differ from object, and there will be some questions like, very simple questions only they used to ask. So you don't need to worry about it. Right. Now, I will give you a question related to your exam. See whether you can do it. Okay. And this is related to the resultant force. Okay. Okay. Now say for example, you have an object. Okay. This object is suspended. Now say for example, this object is fixed. Whenever, okay, now say for example, this object is fixed. Okay. Now this object is fixed. No. So you are giving a force from this edge and you are giving a force from this edge. And say for example, this is going to be the axis of rotation. The center, the place where it is fixed is going to be the axis of rotation. Now what will happen is, say for example, from the axis of rotation from here, it will be 0.25. And here also it will be 0.4. 0.4 meter, 0.25 meter. Let's see how. Okay. And also let's see, the force that is supplied over here is 30 Newton and here is going to be 50 Newton. Right? Now tell me, if I bring my arrow to the axis of rotation, what is the direction of the force? Let's say this is going to be force number 1 and let's say this is going to be force number 2. What is the direction? Is it clockwise or anti-clockwise? Very good. This is going to be anti. This one, I have to bring towards the axis of rotation. This is going to be what? Clockwise or anti-clockwise? This is going to be clockwise. Right. Now my question is, can you find the... Now they can ask you, number one, find the anti-clockwise moment. Anti-clockwise moment. Can you find the anti-clockwise moment right now? Moment of a force. Number two, find the clockwise moment. Find the clockwise moment. Can you find the clockwise moment? And the last one is find the resultant. Find the resultant moment. Resultant moment. Quickly do it. No, simply use the, don't try to convert. Simply use the decimals to multiply. You can do it. Simple, no. Decimal multiplication is simple. Try to do. Rahima is correct. Others? Okay, good. Okay, Hasma also correct. Now both of them are in opposite direction. Since both of them are opposite direction, should you add or subtract? You have to subtract. Both these values have to be subtracted and you have to give the final answer whether it's clockwise or anti-clockwise. Okay? Yeah, try others, try. Only this month you will be like this, and after next month, next month after your exams, you will be free. Try. Okay, Safiullah, that's correct. What's the direction, Safiullah? What's the not anti, resultant moment? Clockwise or anti-clockwise? Joanna, correct? Rahima, you double check. Okay, that's correct. All right, Rihani also correct. Very good. Okay, shall we see? Shall we see the answer? Okay, look here. What's the anti-clockwise moment? What is the anti-clockwise moment? What's our equation? 30 multiplied by 0.25. The answer is 7.5 Newton. That's the anti-clockwise moment. Clockwise, 50 multiplied by 0.4. Your answer is 20 Newton. So, both of them opposite direction. 20 minus 7.5. You get the answer as what? 12.5 Newton. 12.5 Newton towards the clockwise. Now, who is having the highest force? Clockwise. So, that's what we put it as clockwise. Okay. Now, tell me guys, did you feel any hard? Did you feel uneasy? Did you feel uneasy? No, right? Okay. I'll give you one question. Okay. I'll give you one question for those who told okay, we'll give a try. We'll give one more question and give a try. Okay. Can you find the resultant moment of this? Find the resultant moment. Find the resultant moment. So to find the resultant moment, say this is going to be the axis of rotation. And say from here, you are giving a force which is 20 Newton. And here you are giving a force which is going to be 50 Newton. And the whole distance is 1 meter. And say from here to here is 0.5 meter. 0.5 meter. Okay. Can you give a try? Can you give a try, dear? Can you find the resultant moment? Now, I'm not going to help you at anything. Give a try and see. We'll see who can do that well. I will teach you two methods. Easy method. There are two methods. One method is hard method. Hard in the sense a long process. Other one is easy. Like simply you can finish it out. Shafiola, you are correct. Your answer is correct. Shara check. Amna check. Zora correct. Jonna check. No, Ikram. Crazy. Shafni check. Manu Varsan check. Hasma correct. Rahima check. Yehani, your first two answers are correct. Last one, C. Resultant moment. Some people have gone wrong with that. Did you send me message? I didn't see. Right. I will. Okay. Right. I will discuss. Look here. You have to bring the arrow towards the axis of rotation. If you bring the arrow towards the axis of rotation, are they moving clockwise or anti-clockwise? Both of them are towards the same direction. Clockwise or anti-clockwise? They are moving clockwise, no? They are moving clockwise. Okay, both of them are same. Should I add both of this value or should I subtract both of this value? Add or subtract. Both these values has to be added, no? Okay, listen. Now, method number one. Number one, you can separately find the clockwise, both of these forces separately. Say, for example, 20 multiplied by 0.5, the answer is 10 Newton. Okay, here. Now, here, see, this is at the edge. What is the distance? 1 meter, no dear. So, you have to take 50 multiplied by 1 meter is equals to 50 Newton. Now, since we know both of these forces are moving at the same direction, addition or subtraction? Addition or subtraction? Simply tell no. It's an addition, no. So that means 50 plus 10 is equals to 60 Newton meter. That should be your answer. Don't do that mistake. Don't do that mistake. Okay. I told you there's another method, no. Another method is very simple, no change. You can do all of them together. 20 multiplied by 0.5 plus 50 multiplied by 1. Totally, we can take 60 Newton meter. Then you waste your time doing separately. You can do it at once and finish it off. This is my way. This is my way. And this is like your way. I have given a detailed explanation how to do it. Clear with that? Got the idea? Right. Now listen to me very carefully. Now this is related to the drawings. After 0.5, I put equal. That's the mistake. Okay. Hasma, I'll update you regarding the electronics. Okay. Right. Now listen to me very carefully. Now that is a big lesson. Huh? I will try to give you a short update about it. But let's focus on the very easiest lesson in physics. All the easiest lesson finished. Let's go to the hard. Now let's not think about the hardest lesson. Let's say, okay, science is easy. We'll think like that and we'll move on. Now, when you suddenly think, now say for example, now you are in the washroom and suddenly you think the ghost is behind you. Now you are studying. If you think like that, you will get scared. No? But you will think like, okay, no, there's no one behind. I'm just thinking. That's my thought. The same way, whenever you are studying something, don't think the hardest part. Think about the easiest part, the beautiful things. Then you will be consoled alone without anyone is consoling you. So that is the way I learned. Okay? Right. Now, here comes the part. Now, already we studied about resultant moment. Now, we have a different one. Now, say for example, if they say this rod is equilibrium. If they say the rod is equilibrium means, guys, equilibrium means what? Equilibrium means what? What do you mean by equilibrium? We say equilibrium means, another way for equilibrium, we call it as equal. That means clockwise moment will be equal to what? Anti-clockwise moment. What do you need to understand? Clockwise moment should be equal to the anti-clockwise moment. Now you know, whenever in exam, if they use the word a rod which is fixed at up, or if they say the rod which is equilibrium and fixed, remember clockwise moment will be equals to the anti-clockwise moment. Listen to me. Now comes the problem. Now only you are going to the real thing. Now listen. Now say this rod is now fixed. I know you are intelligent, so you can do it. No need to worry. Now say for example, you have a rod and this rod is fixed up. Okay. Now say for example, now the rod is fixed means the clockwise moment will be equals to what? Anti-clockwise moment. Say for example, this is going to be the center. Now, from this center, you will have a object which is at the mass of 2 kilogram, and the distance from this place to this place will be 0.2 meter. Okay, from distance from this place to this place will be 0.5 meter. That means you need to understand, here you will have an object and they are asking you to find the force of this object. Anna, see, now see, they have given you the mass here, not the force, and asking you to find the force. Can you find the force of this? I'll give a try, will you? Give a try. You can do it. Give a try. Can you find the force of this? They said equilibrium. Girls and boys, when they said the word equilibrium, what should be our equation? What should it be? How we should do? That means I told you, clockwise moment. That means what? Clockwise moment will be equal to what? Anti-clockwise moment. Clockwise moment will be equals to what? Anti-clockwise moment. So what is the equation for the moment of force? Force into distance here equals to force into distance here. Simple, no? Do. You can do it. Why not? Why should I help you? Do. You can do it. Do and say me that you understood. Okay. Anna, now you are forgetting, no? Forgetting, no? Now say if they have given mass, how can I convert the mass into force? Another name for force, we call it as weight. Weight is equal to mass into gravitational force. Now find the force, William. Now you should not forget what you learned. Think this is going to be the last day that you have revised. Now again, you are not going to revise this lesson again. Now almost you have revised. You are not going to revise these lessons again. So think like that and do it. You can't see my screen now. Right. Give a try, yeah. If you do this correctly only, we can have one more question.
Yes, Reema. Tired only what to do. But I'm passionately, happily, I'm doing it for you all. So I don't think this is going to be tired. Abdul Rahman, well done. Ashraf, well done. Safiullah, well done. Hasma, well done. Abdul Rahman, yes, correct. Then what about others? Okay, simply listen. Listen, no, this one you have done in your exams and all, like in your term papers and all. Can't you remember this one? Jonna, very good. See here. What is the force? What is the force here? Now see here. Thank you, Isma. Now see here. Now what is the weight here? Now how did you find the weight? 2 multiplied by gravitational force is 20. Force is 20 clockwise. Okay. So that means, wait. I have done differently. Now always you have to bring the arrow to the center, no? So that means this is going to be anti-clockwise. This is going to be clockwise. So clockwise force only you are going to find it. So already the distance is given, that is 0.5, and here let's put it as x, and then equals to what is the force here? 20 multiplied by 0.2. Okay, now what I can do is, since it is equal, can you remember? Since it is equal, you can take the 0.5 to the other side. That means x is equals to 20 multiplied by 0.2 divided by 0.5. So what I can do? I can jump the decimals. So when I jump the decimals, if I jump here one time, here also I have to jump one time. So that means 20 multiplied by 2 divided by 5. Cut this out. How many 5s are there in 20? 4. 4 into 2 is 8 Newton. So that's the answer. Now did you understand? Now did you understand? How did you get this? Okay, let me give you something a bit more complicated, but if you can do it. Yes, Rahima, listen. Now, you know anti-clockwise is equal to the clockwise, no? Anti-clockwise is equal to the clockwise, no? Now listen. Now, what you have to understand is, now the clockwise one. Now, clockwise force only we don't know. Distance is 0.5 and the force is 20. And here we have, now in science or in maths, whenever you have an equal mark, you can take the value that you know to the other side to simplify it and keep the unknown value as a subject. So now what is happening? The person who is in the multiplication, if you take to the other side, that person comes as a division. So now what will happen? If you jump one decimal at the denominator, in the numerator also you have to jump one time equally. So then what will happen? This will become solid 5. This will become solid 2. So 5 divided by 20 is 4. And 4 multiplied by 2 is going to be 8. Clear? Clear? Right. Okay. Give a try for one more question and then we'll go to the couple of force. Okay. Now say for example, you have an object and this object is hanging. Again, it is hanging from the center. From the center. And you are having an object that is 5 kilogram, mass of 5 kilogram. From the center to this corner is 0.5 Newton. And then equally divided. And this side is equally divided. Here it's going to be 0.5 meter. And here it is going to be 0.5 meter. Can you find the mass of the other force? Can you find the mass of this? Can you find the mass of this object? Not other force. Mass of this object. Give a try. I'm just giving to the core. I'm just giving to the core just to understand. Give a try. Now see, if you can do this one means you are great. Remember, if you can do this kind of questions means you are great, because there are students who can't even do questions related to that. But if you can understand within a day, even like, see, all these years you have learned this lesson, you have done papers and you have done so much. And then you can't do any time and you are doing it today means you got the power to do your exams well. That means you have taken your studies seriously and then you are working. So remember,
You are doing it well. Okay, you are doing it. Just don't give up. Keep this spirit. Keep this spirit. Keep working. Keep on moving with the same. Clear with that? Okay, let's see what others are doing. The question is, you have to find the mass of the, let's see, this is going to be anti-clockwise, and this is going to be clockwise. This is going to be clockwise. Can you find the mass of the object of the clockwise moment? Can you find the mass of this? And then someone sent me a correct answer. Who is that? Shafni sent me the correct answer. Very good, Shafi. You will also have sent me the correct answer. And while you do, give me some time. Ahraf also correct. Give me some time. I will be back. I'll have some water and come back. Isma correct. Inzaman correct. Aman correct. Then Shahid, Chekka. Okay. Okay, I'll help you, Rahima. No worries. Tomorrow, biology. Are you joining for biology tomorrow? Because I'll be talking about chapter 14 a lot. Then of inheritance. Then we'll be talking about biological process in human body, chapter 6 of grade 11. And then there are lessons, no? Yes, your answer is correct. Okay, right. Oh, is it Yashani? Mostly chapter 6, I will talk about the important lessons in biology tomorrow. Okay? Right. Shall we discuss? Now see, you guys have been improved. Now last time I saw only very within an hour. Yes. Okay, sure. That's great to know in someone. Okay, right. I don't know whether we'll see. Because all we have to try and we have to check. However, I'm giving everything to you, right? Right. Okay. Now let's check the answer. First, can you find the force of this one anti-clockwise? 5 multiplied by 10 is going to be 50 Newton. That's going to be 50 Newton, right? So what are we going to do is, so we will take clockwise moment is equals to anti-clockwise moment. So clockwise, this is going to be the clockwise moment, and this is going to be the anti-clockwise moment. So anti-clockwise moment, we will take 50 Newton multiplied by 0.5 equals to, how do we take? We will take force is equals to, we'll take the axis multiplied by 0.25. Simply take the 0.25 to the other side. What you can do? 50 multiplied by 0.5. Nicely see, Rahima. 0.25. Now at the denominator, you have 2 decimals. So what can you do? You have to jump 2 times. If you jump 2 times to make it solid, here also you have to jump 2 times, which means 50 multiplied by 50 that is going to be divided by 25. So 25 cancel out with 50. The how many 25s are there in 50? You have how much? You have 2. So 2 into 50 is how much? 100. Why did I multiply it by 10 now? Where did I? No. I multiplied by 100 down. I multiplied here also by 100. Because I can't take only one value, still it will remain as a decimal, no? If I multiply it by 10, it will be 2.5. Can I keep like that? I can't divide a decimal like that. So I have to make the solid as 25. So then up also I have to do the same, similar, since we know they are equal. Now what do we do? 100 Newton is your answer. Already we found the force, that's going to be 100 Newton. Why didn't you add 0.5, darling? This is not addition, no. This is like equal. This is like equal, no. Why aren't we taking 0.5? Here 0.5 is here. 0.25 is here. The reason I didn't take this as a 0.5 because it is substituted by the center. From 0.5 substituted from the center as 0.25. That's the reason we took it as 0.25. Remember, from the arrow to the axis of rotation only you have to take the value. From here to here only you have to take the value. If not, your answer is going to be wrong. So the answer is what? 100 Newton. So force you found it as what? 100 Newton. I'll give another question. 100 Newton. Now since you have to find the mass, how do we find the mass? We know weight. Another name for the force is weight is equals to mass into gravitational force. Already force we know 100. Mass we don't know. What is the gravitational force? 10. Take the 10 to the other side. 100 divided by 100 divided by 10. What's the mass? 10 kilogram is your answer. Clear? Very deep. Very deep and down. Clear? No, up near the anti-clockwise. I multiplied by 10. You mean here? Here is because, Shara, it's in mass. No, I have to convert the mass into force. Then only I can do this equation. Usually mass has to be converted into force. That's the reason. What's the equation for the force? Weight is equals to mass into gravitational into force in order to turn the mass into force. So 5 multiplied by 10. That's why I got it as 50 Newton. Clear now? Okay, who didn't understand this? Very good, Inza. Who didn't understand this? I'll explain one more time. Okay, I'll explain one more time. Those who understood, just be patient. Okay, I'll take one more time. Okay? Okay, listen. Now, they said this is a equilibrium. No, this rod is equilibrium. That means this rod is already fixed. That means, say you are getting, now say for example, you are getting a force from here. Say they haven't given you the force. They have given you the mass. Every time they won't feed you, right? You should be a person to understand clearly. So they have given you the mass. And from mass to here is 0.5 meter to the center of axis of rotation. And from the center of this rod, I mean like the half center of this rod, there is another force is acting, but we don't know what is that force, and they are asking you to find the mass. You have to find the force and you have to find the mass. Clear the and the distance between 0.25 here, 0.25 here, the distance. But always remember, from this arrow to the center of, that means axis of rotation only, you have to get the distance. Now we know this is going to be what? Clockwise, and we know this is going to be the anti-clockwise. So what is going to happen? We know that clockwise is equals to the anti-clockwise. Clockwise is equals to the anti-clockwise. So now what is going to happen? Now we have to find the clockwise side only. Anti-clockwise is already given. So what we can do? So they have given the mass. No, what is our equation for the momentum? Momentum is equals to force into the distance. Momentum is equals to force into the distance. So since they haven't given you the force, you have to convert the mass into force. How do we convert? Weight is equals to mass into gravitational force. So what is the mass? 5. Gravitational force we know 5 into 10 is 50 Newton. So we found the force here is 50 Newton. Distance is 0.5 meter, right? And then why can't we put, I mean, like, which one? Force equals to mass into acceleration. Acceleration they haven't given, no. Acceleration they haven't given, no. So how you can do the acceleration? Yes, this is how the scales will be working. Okay, now listen. So now what is happening here? So force we don't know over here. Let's put it as x. The distance is 0.25. So 0.25 will take to the other side, which is under multiplication, comes as the division. So 50 multiplied by 0.5 divided by 0.25. Remember, decimals cannot be divided. So since that, we make it as a solid by jumping 2 times, which means it is getting multiplied by 100. Here also you will jump in 2 times, which is also getting multiplied by 100. What you do at the denominator, numerator also should be done. So x will be equals to how much? 50 multiplied by 50 divided by 25. 25 cuts off. Here 2 times the 50 will be 100 Newton. Now we found the force, but they are asking you to find the mass, no? Same way what you did earlier, we know force is equals to weight. So weight is equals to mass into gravitational acceleration. So now what is happening? We already know the weight or the force, which is going to be 100 equals to mass. We don't know. Gravitational force is 10. Take the multiplication 10 to the other side. It comes as a division. So 100 divided by 10 is going to be 10 kilogram. Clear the? Understood? Got the idea? Got the idea? Yes or no? Okay. Now let's go to the last part of this lesson. That is going to be the couple of force. We have to study about the couple of force. There is nothing big in the couple of force. Already this lesson is over. So couple of force is only very small part. Now, whenever you talk about couple, are you going to talk about one person or are you going to talk about two person? Whenever we talk about couple, couple means one or two people. So we say couple means we say it is two people. So here you are going to talk about how many force. When we say couple force means how many force are we going to talk about? How many force are we going to talk about? We are going to talk about two forces. Now couple, now when we talk about couple, you will have two opposite gender or similar gender. Will you have similar gender or will you have two opposite gender? What do you think? Usually we will have opposite gender. No? Same like that, the forces will be opposite to each other, or will it be same way to each other? They will be opposite. So we are going to talk about couple of force, which we call it as what? Forces which are opposite to each other, right? So two similar forces in two opposite direction. What do you mean by couple of force? Two similar forces with opposite direction, we call them as what? Couple of force. So when we talk about couple of force, say this is how the couple of force will look like. So in this particular direction, you will have 10 Newton. In this particular direction, you will have 10 Newton. So which means, so you have similar magnitude of forces with opposite direction. We call that as what? Couple of force. Clear with that? But the line of action is different. The line of action is going to be different from each other. Clear with that? Understood that? Right. Now, when you talk about couple of force, now if they ask you to find the moment of couple of force, how can you find the moment of couple of force? Say, for example, they have given from here to here 5 meter, and here to here they have given you 2 meter. How do you find the couple of force here? Moment of couple of force. The very easiest is force multiplied by total distance. So as we know that both this magnitude are same. Are we going to use twice or are we going to use once? We will be using only one force, that's going to be 10 Newton multiplied by What's the total distance? 5 plus 2. What's the total distance? 7. So what can be the moment of couple of force? 70 Newton meter. Clear with that? Clear with that? Lesson is over. Clear with that? Got the idea? Listen, listen. This one, Shafiullah, anti-clockwise moment and clockwise moment also easy. But what I told is shortcut. Shall I say you how? Shall I do that what you told, Shafiullah? Now, listen. There are two methods. Okay. Okay, Rahim, I'll try to give, okay? Okay, now say for example, I'll try to give you personally. If not, we got no time to finish this chapter 12. I'll finish that and I'll go. Okay. Now listen. Now listen. Now what you have to understand here is, now first thing is, I'll tell you, there are method number 1. Method number 1 is, you can take like clockwise moment with anti-clockwise moment. You can take clockwise moment plus anti-clockwise moment. You can take it. How can you take? 10 multiplied by 5. That means force multiplied by the distance plus force multiplied by distance, which means 10 multiplied by 2. So that means here 50 plus here 20. Totally, what is the answer? 70 Newton meter, like Safiullah told me. But instead you give so much of detailed explanation, simply I can tell you my method is, method 2 is force multiplied by total distance. So force multiplied by total distance, how? Force is 10, total distance is 7. 10 into 7 is 70 Newton meter. Which one is easy? Method 1 or method 2? Why do you want to waste your time? Method 2 is easy. Simply you can do. Other than method 1. Yes, this method is only approachable for the opposite direction. They do not come with the same direction, no? Give me some example for couple of force. Opening tap, using a spanner, then opening water bottle. I mean like opening the lid of the water bottle. Then what else? Isn't it working? Dana? Rotation steering wheel, all good. Right. Let's go to the last lesson of the day. That's very simple, huh? Don't think hard and all. Very simple, nothing, no calculation in that. Equilibrium of forces. Equilibrium of forces has no calculation. From that word itself, you can understand. Now, when you talk about equilibrium of forces, so when you talk about equilibrium of forces, the word equilibrium means at rest, or we can call that as equal. So the forces when on the opposite sides are equal, we call that as equilibrium of forces. So equilibrium of forces means the object moving or at rest, the object is at rest. Now say for example, you have equilibrium of forces. Say for example, you have to remember certain things, some conditions are there. Now say for example, you have object, okay, you have an object and this object have forces on the either direction. They have forces on the either direction. Okay. Yes, Atika. So they have forces on the either direction. Now what you need to understand is, on the both the side, forces. What can you say about the forces? Now if the force, let's say if this object is at rest means, what can you say about the forces on the opposite side? Is it equal or is it different? Are they equal or are they different? Very good. They are equal. That means what you can understand is, if you have forces in either side, to find the resultant force, what you have to do? If I have to find the, now say if I say this is going to be 50 Newton and say if I say this is going to be 50 Newton, what can be your resultant force? Your resultant force will be 0 because you subtracted. So whenever you have an object is at equilibrium, you have to remember the resultant force for this object is equals to 0. So if you have equilibrium of forces, the resultant force of that object is equals to 0. So which means the right hand side forces is equal to the left hand side. Clear with that? Got the idea? Yes? Right. Now say if you have forces up and down, if you have forces like this, up and down, now the forces upward should be equal to the downwards. Like we call it as what? Weight and the tension. Now in unit 11, can you remember you studied object at equilibrium, that clockwise moment should be equal to the anti-clockwise moment. So what did you understand? How the objects can be at equilibrium, you studied, no? So equilibrium at two forces means, say for example, you have a bulb and you have hung the bulb on the roof. Say for example, you have hung the bulb to the roof. Say this is the bulb and it is hung. Okay. Is this bulb is moving? Is this bulb is moving? No. What can you say about the bulb? The bulb is at rest. Now, if the bulb is at rest means it is at equilibrium. So now let's see what are the forces that is acting on the bulb. What are the forces acting on the bulb? From the center of the bulb, what is the force that is acting? That's going to be weight. Above the opposite to the weight, what is the force that is acting on the bulb? That is going to be what? Tension. So the object is at equilibrium. No, so this object is at equilibrium. What can you say about the upward and the downward forces? They are equal. That means the tension is equal to the weight. Clear with that? Understood that? Got the idea? Now they can ask you. They can ask you an exam. Now, if the weight is 50 Newton, what can be the tension? What can be the tension? Some people, they can even make a mistake. Even though this is the easiest question, they can even make a mistake. So the answer is 50 Newton. Right. Now, they can ask you, give 3 conditions. If it is not equal, it is not about equilibrium of force. Okay. For an object to be equilibrium under 2 force, there are 3 conditions. What are those 3 conditions? Number 1, both force magnitude should be what? Equal. The direction of the forces should be what? Opposite. Can you remember in unit 11 study, if you have a tap, if you open a tap, what can you say about the line of action? Did they have the same line of action or did they have opposite line of action? They had opposite line of action. When they had opposite line of action, did the tap move? Did the tap move? Yes or no? When you had opposite line of action, they had, now think, like this, no tap. What can you say about the line of action? They had the opposite line of action, no? Since they have opposite line of action, only you can open the tap. But if they have the same line of action, see, this tension and weight, they have same line of action. Can they move? Can they move? Yes or no? Can they move? They can't move. So, what is the second condition to be satisfied? The equilibrium of 2 forces. What is that? Number 1, the magnitude should be equal. Then what else? The magnitude should be equal and opposite. And the number 2 is the line of action of both the forces. Both the forces should be what? Both the forces should be same line of action. And the third one is both the forces should be coplanar. Coplanar means what? Coplanar means what? Both of them should be in the same surface. Clear with that? Got the idea? Got the idea? Yes or no? Right. So then what we have to understand is coplanar means same surface. Say for example, this is one coplanar. This is another coplanar. This is also, we call it as another coplanar. So this is surface. If everything is happening on the same surface, we call that as coplanar. Same coplanar. Do you understand? Clear with that? Okay, right. The second one. Equilibrium very simple. We will finish this. Equilibrium under three parallel forces. So equilibrium under three parallel forces. So now you have a rod. You have hung rod using two strings. You have hung rod using two strings. Say for example, now imagine. Now you have a rod. Okay, imagine you have a rod and you have hung the rod using two strings like this. Okay, and then there is an object in the middle. Think about the banana. Like you have the banana comb, right? Usually there is a big banana comb. They used to hung that in the shop most of the time. Yeah, we don't call it as banana comb. In another time, I could not remember that. But you have a banana. You have banana comb. They used to hang it at the center, right? Now what is happening is, how many tension do you have in this situation? How many tension do you have in this situation? You have two tension. This is one tension, this is one tension. And how many weight do you have? You have one weight. That means if this object should be equilibrium means, what do you need to understand? If this object should be equilibrium means, what can you say about the forces? What can you say about the forces? What are the conditions that you have to satisfy in order to satisfy these three forces? Now, how many tension is there? Two tension, no? It's hung. This person is downward. 1, 2, and this is going to be the third one. How many tension do we have? We have two tension. Okay. So the first one is all the forces should be coplanar. All the forces should be coplanar. Right? What can you say about the upward forces and downward force? We can say both the upward force, say this is going to be tension 1, let's say this is tension 2. Both the upward forces equal to weight. It is equal to weight. So what are the upward forces in this diagram? Tension 1 and tension 2 equal to the downward force, which is going to be weight. Did you understand? So when you have two forces in the same direction, if I want to indicate by a single force, that you call it as what? Resultant force. So according to the resultant force, I told this tension and this tension together, you will have the weight. You will have the same value of the weight. Say if I say this is 20 Newton and say this is 20 Newton and 20 plus 20, this will be equal to 40. That's the reason both of them are at equilibrium. Clear with that? Got the idea? So summation of two forces should be equal to the other forces. Clear with that? Clear with that? So we can say one force should be opposite to the two other forces. Got the idea? Understood? Clear with that? Okay, right. Now let me ask you a question related to that. Now say instead of hanging, say you have a rod and this rod is kept on a heavy, it is kept on a like a heavy rod. Now say for example, you have two parts like this. Okay, you have two parts and this is a rod and this rod is in contact with this particular part. And say imagine when it is not hung. Now say from the center of this rod you will be having weight, but now will you have tension here? Will you have tension here? Yes or no? Then what you will have? Who is opposite to the tension? When tension will be present whenever it's hung, but whenever an object is in contact. Very good, Safula. So whenever an object is in contact with the surface, you will have someone called normal reaction. So we can say the two normal reaction. That means what can you say? When you have two normal reaction, both of these normal reactions should be equal to the weight of this object. So clear with the conditions? So what is the number 1? Summation of two forces should be equal to the other force. One force should be opposite in the direction of two other forces. All forces should be coplanar and all three forces should be parallel to each other. Clear with that? Got the idea? Got the idea? Yes or no? Yes or no? Okay, last part of this lesson, that's about equilibrium, equilibrium under three non-parallel forces, under three non-parallel forces. So equilibrium under three non-parallel forces. Say for example, you have a frame at home and this frame is hung. This frame is hung. Now what can you say about the line of action? You can see the line of action is crossing. They are crossing. Now if I talk about this is going to be the weight, if this is going to be the tension, if this is going to be the tension, all these line of action is meeting at a point that you call it as the center, that is going to be the center of the force, right? Now can you say me, are these three forces acting on the same plane? Are acting on the same plane? Now already I told you it's non-parallel. Are they acting on the same plane? They are not acting on the same plane, but but those things are happening in the same force. We call it as coplane. What can you say about the line of action? All of this line of action is meeting at a point, and we can say that upward forces, are they straight line? No, they are not straight line. Can you find the resultant force here? Is it easy for you to find the resultant force here? No. You will be learning about this in your A levels in detail, but very simply, I can tell you that the result, that means the forces here will be equal. That means, say, for example, the resultant force should be equal and opposite to the other force, but you can't use the word summation. That means this tension and this tension together, you will have the weight, but we can't tell how exactly you will get it. That is what this part, they do not take it much. But if you know non-parallel forces, if we say non-parallel forces means, what you can understand, the line of actions are different and they are at the same coplanar, and you can't use the summation. That means the tensions won't be combination of two tensions. We can't tell it will be equal to the weight. But we can say this tension, weight, all of them can be one magnitude. All of them can be one magnitude. Let me give a question to you. See whether you can understand. If you understand, the lesson is over. Okay. Now say for example, I will give you a non-parallel force here. I will give you a non-parallel force. Say for example like this. Now I have given you some angles. Say for example, this angle is 120 degree. If this angle is 120 degree. If this angle is 120 degree. Okay. Now say the tension 1 is equals to 10 Newton. Can you find the tension 2 value? And can you find the value of weight? What will be the value of tension 2 and what will be the value of weight? Quickly tell me. Very good, Mariam. Very good, Rahima. Okay, listen. 120, 120, 120. If 120 is equals to 10 Newton means all three people have 120 means this tension also will have 10 Newton, this weight also will have 10 Newton. Now did you understand? Now did you understand? Right? Lesson is over. We will have the other set of lesson. I'll update you the date. Hope you will not miss the biology part, because biology we will not take any. We won't be taking any more days for that. And however, we'll be finishing like important lessons under biology, and I'll be giving an update regarding that. Okay. What is collinear? Collinear, we call it as same line of action. Coplanar is different from collinear. Collinear is like one after the other. Okay, so I hope you may have understood the lesson. You got an idea regarding that. And I will do the heat, inshallah. I'll give you an update regarding that. And biology tunes, I'll be updating right now with the things and all. I'll update you the days for the physics right now. I can't think. So, right. So, anyways, thanks a lot for waiting and have a good day. Take care. And if you like my class, just let me know. Would be a great help. And also, take care. See you. Don't give up.
Means a lot. Take care. Bye. Walaikum salam. Bless you too, Hansika.